which is simply being classified. Okay, and this classification problem is in itself such an important one that probably it can be referred as the classification or rather the definition of a very big area of study, which is referred as science. So science is a systematic classification of experiences. Okay, that's a quote given by Lewis. Okay, so we are also going to talk about certain classification. This tool which I'm going to talk about is a tool which is referred as for classification purposes as well. As a part of business analytics or analytics domain, classification is again one such field, and where the current topic which I'm going to discuss today is actually being used extensively. Is one of the way in which the classification algorithm works. I will probably for today. Okay, I can continue to read your chat as well. So if you have any quick query, okay, I can respond it on the spot. Otherwise, we can keep a discussion at the end of the session for any extended discussion on any particular issue which you might face. So any quick question which you might have, okay, I can refer to as we go ahead. Okay, so where exactly, okay, the entire theme lies. Okay, you have by now have learned about or listened to various speakers on the regression model as well. And one of the key questions which I'm going to pose today, okay, and which you probably I expect, okay, some clarity by you, is that okay, so if you have a variable, you have in a typical regression model, you have a dependent variable and you have independent variable. If one of your variable happens to be a dummy variable, then probably how you are going to handle it. Okay, so there are three possibilities I have been putting up here. Suppose X is a categorical variable. Okay, it's a dummy variable. It's like something like gender, male or female. It's like any other success or failure, any Bernoulli function. It's like, okay, whether you have passed or you failed, okay, whether you tested for corona and it is positive or negative, okay, things like that. Okay, if you have this kind of a variable, and that variable happens to be categorical in nature, and if this is one of the independent variable, if that happens to be the case, okay, we are perfectly fine. We can run a regression. We can include that categorical as variable as our one of the independent variable, and we can simply go ahead with running a regression. That's not much of a problem. Okay, we are not much affected by the fact that one of your variable happens to be categorical one. The second is, okay, if this is the only independent variable, so why is your any other continuous variable or ratio scale variable where regression analysis can be applied, while X happens to be the independent variable or the only independent variable in the list of independent variable. Okay, so in that case, you can still go ahead with the regression. Okay, that's still not an issue at all. Okay, so if Y is your, let's say, salary and X is the gender, okay, you are perfectly fine. Okay, you can simply still go ahead with the running a regression. However, what you could also alternatively resort to is that you can also apply ANOVA. So for the second case, you can still apply ANOVA. The third situation which I've been taking is, okay, that categorical variable, okay, gender, pass, fail, okay, a test positive or test negative, if that happens to be dependent variable, okay, then what to do in that case? Okay, so again, if that happens to be the situation, then we can still continue with that. We are not having much of an issue with that as well. So we can still run a regression and that will not be much of an issue from our part as well. But okay, there could be certain alternative which has been available. So our focus for today is, okay, when your X, which is your categorical variable, happens to be the dependent variable. So what we are referring is, okay, if you are looking for some of those categorical variable, which are your dependent variable, like customer churning, will your customer go to somebody else, will go to some other competitor? It is credit rating, okay, whether you have rated AAA or whether triple B or double B or C. If it is employee attrition, will the employee remain in your organization or not? Whether it's a detection of fraud, there is a accounting fraud which has happened in the firm or not. Whether a proposed merger will be successful or not. Okay, these could be some of the examples.
आंसर डिस्कनेक्ट हो गए क्या?
Yes.
अंजलि मैम?
Yes, ma'am.
अंजलि मैम? Okay, I'm calling ma'am.
Hello?
Hello?
Narayan sir? Okay.
Am I audible now?
Yes, sir.
Yes, sir, but your voice is very low, sir.
Am I still audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, can we go ahead and okay, I think, okay, sorry for this technical glitch. So, but let's continue with what we are referring is that, okay, various situations in which we can have.
Your voice is very low, sir.
Hello?
Your
Am I
voice.
audible?
Yes, sir.
Still
Yes, sir.
very
It
low?
is clear.
Okay, so what we are referring now, as of now, is okay, various cases in which we can refer to dependent variable being categorical in nature. If so, if you are looking for some of these cases, okay, then something which we can resort to is referred as our the logic Probit models, okay, which we have been referring to. This is one such field where okay, your dependent variable happens to be a dummy variable, a categorical variable, and you have the list of independent variable which we can refer to. We refer this kind of model as dummy variable model or qualitative response variable model, binary variable, discrete choice variable, limited dependent variable. These are some of the terminology which is also being used. So this is a tool and technique where your dependent variable happens to be a categorical variable.
Yeah.
I think I'm hearing across voices. Okay, so this takes us to our topic for today, which is linear probability model, Logit, and Probit. If you simply go ahead and run a regression, okay, then you have okay, linear probability model. But let's come back to it a bit. So the topic for today is a dependent variable, okay, which happens to be a binary choice. Okay, so there are only two categories which have been defined. So suppose you are referring to a rating, credit rating. So in credit rating, you might have AAA, AA, single A, triple B, and so on. So you have multiple choices. Okay, so it's not just two choices, male or female, pass or fail. Okay, test positive, test negative. It is if it is more than two. Okay, then instead of binary, you might have okay more choices in your dependent variable. So I'm not including that for the current session, but you can have a multinomial logic version and multinomial Probit version as well. Then I'm been referred to a data set which is categorical in nature. Okay, what I meant by categorical is that okay, it's simply pass and fail. It's test positive, test negative, but there is no order. Okay, if I again continue with an example of credit rating, a triple A is better than a single double A. Okay, a double A is better than a single A. Okay, and so on. So if there is an order in the dependent variable itself, then that's been referred it as the ordinal logistic regression. So which is again I'm not taking. So I'm taking where a case where the dependent variable is binary and categorical in nature. However, if you want to go for that, okay, that will be simply an extension which you can always refer. Okay, so let me take a specific case, a file for which has already been shared with you. It's an interesting case reported in there in many textbooks, including Gujarati's text itself. Here we are having a Ray Fair's extramarital affairs model. Wherein he collected responses from Psychology Today, a US magazine, and he published his work there as well. So what he was trying to assess is, okay, okay, what are the factors which contributes in okay, a person indulging into an extramarital affairs? So for one of the okay, so it's just simply whether the person has an affair or didn't had an affair last year. That happens to be the discrete choice variable, a binary choice variable. Okay, with no preference, having an affair is better than no affair, okay, or vice versa. So that happens to be simply a binary without any ordinal order, which has been referred there. And the various parameter which it has been collected is gender of the person, okay, which is of the respondent, male or female, female being 0, male being 1, okay. Number of years for which the respondent has married, children, whether the person has a children or there is no children. Again, religiousness, okay, that's one more factor, which is scaled from 1 to 5, 1 being anti-religion and 5 being the most religious one. Education in years is also been computed, okay, and that is also taken as a factor from basic elementary school to a PhD and plus okay, a postdoc or something like that, okay, that's also been taken as one more variable. Occupation of a person, okay, that's on a Holling had scale from 1 to 7, that's also been defined. And the satisfaction of the respondent with the marriage is also been defined. From 1 being a very unhappy with the marriage and 5 being a very happy in the marriage. These are the 7 variables which has been considered, and the dependent variable happens to be whether the person is indulging into an extramarital affairs. Okay. So that being a dependent variable and these 7 being an independent variable, okay, and we just simply try to assess what kind of model, what kind of factor contribute to the person indulging into an extramarital affairs. If you simply take dependent variable and independent variable and still go ahead with running a regression, which is your typical tool of OLS regression itself, then that's you can always run on, okay, and you can simply get those variables itself, which is trying to contribute to explaining what how does these independent factors try to contribute in that case. Okay, so simply you simply go ahead running a regression without any much of an issue. Now, if you continued in that way, okay, probably does the things pan out, okay, what is it will be called, okay, I'm just skipping the jargons which has been used here, okay, and if you simply run a regression, then this kind of regression, without giving heed to the fact that this dependent variable is a categorical in nature. Whether it's a categorical or not, okay, you simply run a regression, those 7 independent variable, and this have, affair as the variable, which is as dependent variable, okay, and then you can simply run a regression that's been referred as linear probability model. Okay. Let me just run that regression in SPSS and show you the output and see, okay, how does what are the factors which contributes to it. So I have that SPSS file with me, okay, and I simply run a regression, a simple regression. You might have already done that, okay, in one of your previous sessions. So let's go ahead with that. So let me just swap. I simply go to data set. Are you able to see the data set? Okay, I'm just change my screen sharing. Would anyone confirm? Okay. Okay, so this is a data set where gender, male or female, okay, number of years married, children, religiousness, education, occupation, marriage satisfaction, and affairs, okay, that all the variables has been there, okay, so whether the person is male or female, no child or having a child, person is anti-religious or religion, okay, and all those have been there. So whether the person has an affair in the past year or not, okay, that is a data set. So I'm simply running a regression, go to analyze regression, linear regression, and I take affairs as the dependent variable and all these as my independent variable. Okay. And let me just have a save here. Okay. So let me save what are my predicted values which are unstandardized. I'm not using much of the other data set, okay, and I'm simply taking it and simply go ahead, okay, press OK. And this is simply what you will do in a simple linear regression model. Okay. So I'm just showing that itself. So I simply press OK. Okay, there's an output view. Is that screen is also being visible to you all?
Yes, sir. It is visible.
Yeah. Okay. So what I've been having here is a simple regression model where your regression R square is 0.094. Okay. Your ANOVA tells you that yes, model is somewhat a good fit. It's having a significant value. And these are the various coefficients which we have estimated in that case. Okay. So my dependent variable is the variable of affair, and we find that gender is not significant. Okay, so whether the person is male or female does not affect whether the person will go for the extramarital affair or not. Okay, number of years married is also not a significant variable, but children, having children is a significant variable, and it positively affects the dependent variable. Okay, so likelihood that if the person has children, and there are chances the person will go for an extramarital affair. If a person is religious, which is having a negative sign, then in that case, okay, the person may not be go for a extramarital affair. Okay, so if higher on the religiousness score, okay, lower is the probability that you might indulge into extramarital affair. Education has nothing to do with the extramarital affair. And again, occupation has again not having any impact on the indulging into the extramarital affair. The probability in which you might do this. Okay. Then marriage satisfaction is also very important score, which does affect the person indulging into an extramarital affair. If we simply swap to the data view, okay, because I've recorded the predicted probabilities. Okay. So I have these predicted probabilities with me. Okay, so based on the model, linear regression model, predicted value of y hat cap, y star is been noted here. Now, if you simply, what I'm simply been doing it is I just sort these cases. So I'm just sorting from lower probability to higher probability. I'm just sorting these this particular variable. So I go to data and sort cases. I'm just sorting it on the basis of predicted value, ascending order, and I simply press OK. Now we have all predicted probabilities which have been listed here. Now, what has been interesting, which you can refer to, is that you can note here that my dependent variable, which is the probability of the person will be indulging into extramarital affair or not, I'm finding it negative. Okay, and from here onward, these are all positive. So there are negative probabilities, and then you are having a positive probability. Now, by definition, a probability is a measure which varies from 0 to 1. So either you have a 0% probability or you have a 100% probability, but okay, you don't have a mechanism by definition where the probability can be negative. And also there is no mechanism, okay, there is no definition in the term that you have probability which is greater than 1, which cannot happen. Okay? So if you continue to use dependent variable and run a regression on, then you will not be able to run. You will not be able to get a correct value of the probability. You'll find pretty hard to interpret some of those results wherein you are having a negative probability, because theoretically you doesn't have an explanation for a negative probability. So then what is a way out? Okay, so is this model workable? Okay, if you get some of these within range probability, then it's fine, but not in all cases. Okay, so running a simple linear regression, or what is referred as linear probability model, okay, you can still go ahead and there's no problem. But at times you might find some of the problems which I just have pointed out. So this was the result which I have just shown you using the SPSS, okay? And this was a kind of function because you linear put a regression in that case. Okay, so this linear regression line has been a fit line which we have. Okay, so can you have any other problem if you have been running this kind of a regression model? The answer is yes, there are typical 4 problems which you might encounter. First is when you run a regression, one of the assumption of a regression model, which is not a necessary assumption, happens to be that your error term is a normal distributed. Now, in this case, the error term is not supposed to be normal distributed. It is supposed to be binomial distribution. There are only 2 possibilities which are in. Either a person is into an extramarital affair, or a person is not into an extramarital affair. As simple as that. There are only 2 possibilities. It's not a minus infinity to plus infinity kind of range which the normal distribution might assume. That's one problem. Linear probability model does not recognize that your variable, dependent variable, is not a normal distributed, but rather a binomial distributed one. Let's take the next one. Okay, there's one more problem which the data set has, and that is one of more assumption of a regression model is that the data which you have been referring to is homoscedastic. It has an equal variance. But again, that's not a case here. Here the variance is a function of mean. As the mean goes up, variance also goes up. Okay, so along the line, the variation is actually been increasing. So the this particular regression model also suffers from the problem of heteroscedasticity. The third problem which we might have is that whenever you use that R square, remember there in that output we were having 0.09 as the R square for the model. This particular R square has not much meaning in a linear probability model. And if you repeatedly compute it, you will find that it will be much lower than the value 1. Okay. So we are having a conventionally computed R square is likely to be much lower than the 1. So you will never achieve the value of 1 if you still continue with the linear probability model. Then another problem which you might encounter is that, which I have shown you, is that the probability measure, okay, which was supposed to be varying between 0 and 1, okay, but if you make a prediction, it might be even less than 0 and less than 1. Okay? So this might also be one more problem which you might encounter in running a linear probability model. As a result of which, linear probability model is not much applied in these cases, and we resort to some more sophisticated model, which happens to be the Logit and Probit model itself. While the other three problem is not a major problem, you can always handle heteroscedasticity. There's not much of a problem there. If the data is not normally distributed and you doesn't need to indulge into hypothesis testing, again, normality is not required. The third problem that what we were having here, the R square. So we can compute a different measure of R square. That's also not much of an issue. But this fourth problem is a major problem, and which makes us to go for some kind of a nonlinear relationship, because otherwise your probability will cross the mark, the limit of 1, or it might go down and become negative as well, which we have seen with the current data set. So how to ensure that the probability is lying between 0 and 1? Okay? And only then you make a prediction. What is the probability that person indulges into an extramarital affair? So it should not be more than 1. It should not be less than 0. Only then you can work with that kind of a model. So if you use those kind of mathematical modification, then two such mathematical modification are prescribed in theory. One is the Logit model, which uses logistic function as a mathematical transformation. And second one is the normal probability distribution model, which is referred as the Probit model. So using a normal probability distribution, we can apply a Probit model. Otherwise, using a logistic function, we can apply the Logit model. However, any mathematical modification which makes the probability to vary only between 0 and 1, not beyond 1 and not below 0, okay, can also be applied, and the similar model can also be drawn. But there will be mathematical complexity in terms of their interpretation. So if you simply use the standard normal probability distribution for making the regression model, then you can refer to that as your normal the Probit model. Now, what happens in the Probit model is the modification which is being resorted to happens to be coming from the
So your video audio is paused.
they fall into a genre of the nonlinear model. So here we cannot use simple OLS. Here we have to use the maximum likelihood method, and that can be used for the estimation purpose. So if we again apply this Probit model and run a regression in SPSS, then how does the output is being generated? Let me just go ahead with that. So I'm again going to my the data set, and I will now be computing the regression model on the same data set using the Probit analysis. So I go to analyze, I go to generalized linear model, okay, and I go for generalized linear models. This category of non-linear regression models, with a transformation, they can be made linear. Hence, the respective tool or this broader name assigned to them happens to be the generalized linear model. There's something called as a general linear model, and there's something called a generalized linear model. Generalized linear model can handle some of these. So let me take it to generalized linear model. I go to here in the generalized linear model dialog box, I go for binary Probit. Okay, binary means there are only two values, and the Probit is the transformation which I've been referring to. I go to the next tab, which is response. So I pick up affairs as my dependent variable. Then it also asks me what is reference category. So what is the benchmark category? So here I'm taking my benchmark category as the lowest one. Okay. So what I'm just trying to say in this case is, so if my benchmark is a person who is not having an affair, okay, that's my benchmark. So what are the factors which makes a person, okay, who is not having an affair to indulge into an affair? So my base case, my benchmark in that case, my reference category becomes my the zero category, where the person is not having an affair, and then what are the factors which leads to or indulge the person for an affair. And again, continue here. Okay. Then I go for predictors, and in this case, I take all other variables, and I simply select them and go for covariates. Okay. Except that predicted value from the linear regression model. Okay, that's not I'm not putting it into my one of the variables. Factors will be having, okay, if you have a dummy variable with more than 2 categories, then that could be classified for factor purposes. That may not be applicable for our case, so I take all the variables here, go for model, and I pick up all the factors, all the variables, and put it into my model, and I go for estimation. I'm not changing anything. On the statistics, I'm having all these values. You can include the exponential parameter estimates as well. And not much I'm been changing in this case. Rise mean, save. Predicted value of mean response. That's what I could say. Let me just not indulge into much here. Okay, simply press OK. If you now press OK, so we are able to successfully run a Probit model in our analysis. Okay, so reference category, what I was referring to was that, okay, what is your benchmark category and beyond which you are looking for. So suppose that you want to assess whether if a person is, in this case, okay, if a person is not having an affair, that's my benchmark, that's my reference. And if a person goes for an extramarital affair, then that will be my add-on. So what is my add-on? What is my benchmark? Okay, is a base case. You can pick up any one. Okay, so depending upon from where you have just simply been looking at. It makes much more sense when you have a multinomial version, but Probit as well. Okay, that's a necessary input. So I'm getting some output here, generalized linear model, Probit-based analysis. So my dependent variable is affairs, and I'm using the probability distribution binomial, and the length function is a Probit one. So again, I go for, okay, there are a couple of goodness of fit measures as well. So we'll talk about log likelihood, okay, somewhat in more detail. So that's also been reported here. Pearson chi-square, that's also been there. So some of my goodness of fit measures has also been reported here. And let me just go ahead further. Okay, talk about likelihood ratio. Okay, we'll come back itself. Okay, that's more test, okay, which is equivalent less than 0.05. So we are saying that our model is relatively a good fit model. You know, our linear probability model was also been coming out to be a good fit model itself. And here again, I have my regression output presented here. If you just look at these are my all the independent variable, their coefficient value, okay, their standard error, and the hypothesis test I can okay, place it here. So these are my significance levels here. So again, gender is not coming up as significant. Number of years of marriage is also not coming as significant. Religiousness is coming up as significant. Sorry, children is coming up as significant, and it has a positive sign. That means if you have children, there's a higher probability that person will indulge into extramarital affair. religiousness is having a negative sign and it's also significant. So if you are more religious, less likely that you will be indulging into extramarital affair. A marriage satisfaction is again a negative, and it's a significant that if you are not satisfied with your marriage, so then you are likely to indulge into extramarital affair. And if you are having a higher score of marriage satisfaction, then you are likely that not indulge into extramarital affairs itself. So we are also getting a similar result. So that's not an issue at all. So linear probability model, and this is also giving me a similar results itself as far as the sign of the coefficients are concerned. Okay. The question. Yeah, it doesn't make much of an issue as far as my right hand side is concerned. Okay, so whether you have a categorical variable or you have the continuous variable, whether you have ordinal level variable, okay, that's simply not an issue at all. So number of years marriage is a continuous variable. Whether you have children and you do not have children, that's my categorical variable. And your education or occupation or marriage satisfaction from 1 to 5 level, that's an ordinal level variable. That's not an issue at all as far as my the quality of independent variable is concerned. Okay, so that was my Probit model. Okay, and we can again further continue with that itself presentation. So, so my Probit output is just what I've shown it to you. Okay. Now let's start with the Logit model. In the case of Logit model, again the transformation is being done, and this transformation is just to make sure, just to handle the fourth problem with the linear probability model, that your probability has to lie between 0 and 1. Okay, remember that your linear probability model has nothing inbuilt which ensure that probability will never go below 0 or will not cross the level 1. Okay. So we are just mathematically making sure that probability does not cross those limits, and at the same time we are able to do some kind of analysis in the sense that hypothesis testing and regression result can be generated, and you have a optima which has been obtained. So this is one more transformation which we can have, and here the mathematical transformation is in terms of what has been referred as a sigmoid function. Sigmoid function is generally function which are of S shape. Okay, so there is an S English alphabet letter S which has been created out of these sigmoid function. There is one such mathematical transformation which ensure that your probability value will always lie between 0 and 1. Okay. I'm not getting more, too much into the mathematics of it, okay, but that's also one more version which you can also try with the Logit itself. In the case of a Logit transformation, what you compute is something called as probability over 1 minus p, which is your probability of indulging into an extramarital affair divided by the probability of not indulging into an extramarital affair. So if there's 60% probability that you will indulge into extramarital affair, and so not indulging into extramarital affair is a 0.4, 1 minus 0.6. So 0.6 divided by 0.4 is referred as something called as the odds ratio, and a natural log of that is referred as the logit. Okay. So hence the word which we are referring that as a logit. Logit is the odds ratio, probability of success divided by probability of failure, and a natural log of that. That's the kind of transformation which is being done for running this kind of a regression. So we are running something like this one. So logit to a variation, and which is equal to y alpha plus beta 1 and x1, where x is a vector of all my independent variable. So age, gender, okay, all these factors will become your independent variable. The dependent variable is no longer simple probability, but a natural log of the odds ratio. Again, similar to my Probit model, this is also need to be computed using the not as an OLS, but a maximum likelihood ratio only. Okay, so probably some of these I'll come back at which model okay I can go for. So if you again run this kind of model you under the Logit version itself, okay, so we can run that itself. Let me again run the same model using the Logit version. So I go to Analyze, I go to Regression, and I go to Binary Logistic. Okay, this is what I will be referring to when I've been computing these, generating these outputs. So I go to, for this one, Logistic Regression. It's a binary, only two choices. I take affairs data as dependent, and I'll take all other independent variable, excluding the unstandardized predicted value coming from the linear model. Okay, and I have these values with. I simply explore some of those other options itself. So I go for categorical. I'm not changing much. Save. In the save category, I want to have probabilities. I want to have a group membership. Okay, I'll come to it slightly later. I'm not looking for the other one. I go for options, and I have classification plot, Hosmer and Lemeshaw goodness of fit. Okay, this is what I can also refer to. I'm not changing much in this case. I'm still using cutoff probability as 0.5. Style and bootstrap I can ignore for the time. So let me have some of these itself, okay, and simply go for OK. Okay, so we are again able to successfully generate the result for the logistic model. There are no missing values, 601 observation, all are been there. My classification table, I'll come back to it slightly later. And variable of equation, which all I have considered. Then goodness of fit measure, omnibus test. Okay, they are all telling me that the model is significant one. The log likelihood was also coming up as for one of the measures for model selection. Hosmer-Lemeshaw test, okay, it's not giving me much of a change. Okay, it's telling me that it's not a significant one, and this is my final output with respect to the independent variable. I'll come to some of those parameters slightly later. So this is again a similar result I've been getting. Children is having a positive relationship with the probability of indulging into an extramarital affair, and it's also significant. Religiousness is negative and significant. Marriage satisfaction is negative and significant. All other variables are not coming up as significant itself. So I'm again getting a similar result. So whether linear probability model or Probit model or a Logit model, I'm getting a similar result. Okay, but the problem with the linear probability model is that your probabilities can come up. Okay, not in all. It's not a necessary thing. But probability could be greater than 1 or could also be less than 0, which may not be the case with the Logit and Probit models. So how does exactly I'll take up some of these questions at the end. Okay, so I'm also getting a similar result using the Logit model as well. So let me continue in this case. Okay, so this is what my Logit result. Now the question is how to say whether which model is a better fit model, which is the best fit model in our case, whether it's a Logit or a Probit version. So what you do in a normal regression model, we have for goodness of fit something called as an F statistics and R square. This is what you see for the interpretation purpose. Similar to that in Logit Probit case as well. We have something called the likelihood ratio test, which is the equivalent of the F test. And we don't have R square, but a pseudo R square, proxy R square, which can also be used for similar instances. So I'm just drawing parallel between a logistic regression and simple normal regression, which is generally run. In normal regression model, you also have a T statistics, and here we have the Wald test, which is an equivalent for the T statistics itself, which can be used for individual variables, whether they are significant or not. Can we use simply the R square as a measure of goodness of fit? The answer is no. Here, remember, linear probability model was having a problem with the R square. It was always been under reporting. So here again, there's no concept as such of R square, but you can have a proxy of the R square. So there are multiple proxy which you can use. There's something called as a log likelihood statistics, because we estimated these results using maximum likelihood. So there's a log likelihood which you can use instead for model selection as a goodness of fit criteria. Then there's something called as a likelihood ratio, which is the ratio of log likelihood function of restricted and log likelihood function which is unrestricted. While restricted one is, suppose that you use no other variable, no other independent variable except a constant. Okay? Then that becomes a restricted model. You are restricting that the probability of indulging into extramarital affair is not affected by any other variable. So you take log likelihood function value of a restricted divided by the unrestricted one, to get something called as 2 times log likelihood ratio. This is one such ratio which you can use instead of similar to the one which is an F ratio, F test in your normal regression models. Other measures which you can take up is something called the McFadden's R square, okay, which tells you that how good your model fit is. Okay? And generally a McFadden's R square between 0.2 to 0.4 is preferred. Then there's something called as a Cox and Snell R square measure, okay, which is again defined by this mathematical version itself. These are all pseudo R square which are not actually R square in normal regression version, but an equivalent of the R square in a logistic version itself. Another one which is Nagel-Kirke's measure, which ensures that your R square varies between 0 and 1. Okay? While the Cox and Snell version doesn't approaches the value 1, but this modification of the Cox and Snell's model, which is Nagel-Kirke's version, here you are able to ensure that R square will actually be varying from 0 to 1 itself. And the last one, okay, which you can also take it as an R square, is Hosmer-Lemaichaux's R square version. Okay. This is again based on log likelihood of restricted and unrestricted one itself. These are some of the R square numbers which you can pick up for the model goodness of it. So if I again go back to my output, okay, so we have we computed the Hosmer-Lemaichaux test, which was R square. It's not a very good test, but still it's a much more reported one. So you 2 times log likelihood number, Cox and Snell R square, and Nagel-Kirke's R square. These are some of the numbers which you are getting. Remember, okay, our log likelihood in a linear, R square in a linear probability model was also coming as 0.09. Okay, but it's a 0.13, which the Nagel-Kirke's R square is generally been reported for. It varies from 0 to 1. Cox and Snell will never go to 1. Might come to close to 0, but never approach 1. But this will approach 1. So R square, an equivalent version in a pseudo sense, it's a 0.13 number. So these are some of the tests. Omnibus test for the chi-square, which is log likelihood version, likelihood ratio test, which are significant. So we might be saying that, okay, the model is a good fit. Okay, some more model choosing criteria is here, okay, and Hosmer-Lemaichaux test. Probably banking ourselves on Omnibus test of model coefficient is much very widely reported. Okay, so probably let me answer, okay, one such question which was put forward immediately, okay, when I run the 2 models. Which one we should choose, Probit model or the Logit model? It's not much of a difference, Logit versus the Probit one. The main difference is that probably logistic regression is comparatively slightly fatter tail, okay, as compared to the Probit model. So the probability of an extreme value is more in the case of Logit model as compared to a Probit model, okay, which is generally for certain financial data set, you will find this fatter tail is a more widely available phenomena. Hence, there is a general preference for the Logit version as well. Okay. Second thing is the Logit and Probit coefficient are not much different. Okay. Probably you can derive a Logit coefficient on an approximated basis from a Probit coefficient and vice versa. So pi value, which is 22 pi 7 or 3.14159, okay, and divided by square root of 3, which comes close to 1.8 something, okay. So if you multiply a Probit coefficient by 1.8, you can get Logit coefficient itself. So one can be transformed into another, so that's not much of an issue. But okay, for mathematical simplicity and the ease of manipulation, okay, Logit model is generally preferred by practitioners and researchers over a Probit model. Okay. So as far as the choice is concerned, it's okay, much of an issue. The first thing is, okay, logistic regression generally adhere to some of the financial data set phenomena of having a fatter tail. Okay. So if you're not working with a financial data set, okay, then there will not be much of a difference between the two. And Logit model provide much more mathematical flexibility. So as far as the interpretation of coefficient is concerned, most often okay, we make interpretation based on the sign. Okay? The individual amount, the quantum of the coefficient is generally not commented in most of the papers as well. What do I mean by that? Okay, is that okay? So what we are simply trying to say is that okay, what is the probability the person will indulge into a extramarital affair? Okay, does it relate with the marriage satisfaction of the respondent from the marriage? Okay? The answer is if you are simply been thinking that if a person is more satisfied in the marriage, okay, is likely to not indulge into a extramarital affair. So what you are trying to comment is only on the sign, whether it's positively related or negatively related. So we are saying it should be negatively related. Okay, so that's pretty much fine with us. But if you really want to comment on the magnitude, one unit change, okay. So if you become much more satisfied in your data set, okay, or in terms of let's say any continuous variable, if the number of years of marriage is concerned, if a person is married for almost 50 years, okay, then can we say that there is a possibility that a person will indulge into extramarital affair? Okay, so there you might be interested in knowing for one extra year of marriage, okay, spending it in the marriage, will that give how much reduction in the probability it might have? Okay? Then there will be an interpretation issue, a serious interpretation issue, okay, which has a mathematical repercussion. Much fine, will not have much of an issue with the interpretation. For example, children and the probability of indulging into extramarital affair. So if more the children you have, okay, probability of the extramarital affair will be more. Okay. The religiousness and the probability of indulging into extramarital affair, if the more religious you are, okay, there's a fall in the probability of indulging into extramarital affair. Similarly, the marriage satisfaction versus the probability of extramarital affair. So if more is a satisfaction in marriage, the less is the probability in extramarital affair. If you are really concerned about the size in that case, okay, so need to make an interpretation in terms of the amount involved. So one unit change to another unit change. For example, having a children was coefficient was 0.7 fixed. Tells you that 71.6% increase in the odds ratio. That's where all the complexity comes up when the person have children. Okay? So if a person have children from 0, no children, to 1, which is person having a children, there is 71.6% increase. Not the probability, but it's an increase in the probability when the person was not having a children, okay, into the odds ratio. Now, what is an odds ratio? It's this same number, p upon 1 minus p number. So probability of extramarital affair divided by not having an affair. That probability, that ratio of two probability will increase by 71.6%. I know it's somewhat difficult to absorb for the first time, okay, but when you start reading it again and again and look for the data set, only then you can master it. Okay, probably at this stage, okay, just simply one simple session, you may not be able to comment, okay, and master it. Okay, one go itself. Okay, let's move further. Okay, and this is what exactly is that mathematical expression that if you're simply looking for, you want the probability versus the individual variable, okay, then you really have a hard time to making an interpretation. Sign wise, okay, you will not have a much of an issue, but if you're really looking for 1 unit change in independent variable, then how much the dependent variable change, okay, then there you need to get to the maths around it. Okay. Now the next thing is we also made and saved some of the variables. Okay, let me just show it to the data set. Now here, now you can see it. This was the original data set till affair. These were all the variables which I was having. Predicted probability value 1 was coming from linear probability model, which I'm not considering as of now. And this is the predicted probability using the logistic regression model. So you can see that in linear probability model, you were getting negative probability values, but here you are getting positive probability values. So there's no way in which you can get probability values which are less than 0 or probability values which is greater than 1. That was the entire setup for us, because we really set up the entire thing so that there is no violation of the definition of probability. It cannot, has to be between 0 and 1 only. Okay. Those marginal effects, okay, probably that's what I was skipping for the time being, because that you have to get through the entire mathematics of that. Okay, so that double derivative okay, number which I was referring to, those are my marginal effects, the logistic regression model. Okay, so then this was also been grouping, which has been done. So generally the default grouping variable happens to be 0.5. So if my predicted probability is less than 0.5, okay, this is 0.05, not 0.5. And obviously 0.05 is less than 0.5. Hence you are putting into a category that a person is not having an affair. Okay, somebody which is greater than 0.05, somewhere down the data set. Okay, somewhere here, let's say 0.60, which is greater than 0.05, you are putting into a group that a person is likely to indulge into an affair. Okay, so we have also grouped this kind of data set as well. Okay. So these are my predicted probability, and I'm able to ensure that as well. Okay. What I was also referring in this case is how to what is this threshold of 50%? Don't you think that this threshold is an arbitrary one? Okay, so person having a probability of 0.05, okay, is grouped as not having an affair. Person having a probability of 0.6 is put up as having an affair. So this 0.5 was a default in our case, but can you change it a bit? Okay, and why should you change it? That's what I will be now focusing on. So if I refer to this kind of version, okay, then what has been suggested for us is that we prepare something called as a confusion matrix, or the classification table. Okay. So we can make a prediction of the person having an affair, and we can need to put certain threshold, because it will only give you probabilities, probability 0.5 or 0.4, 0.9, 0.8, 0.6, okay. And what makes a person, okay, what is my cutoff that I will call it as that above that probability, the person will be grouped into having an affair, okay, and below that probability, will group them into not having an affair. So that can be used using a classification table, and my classification table looks like something like this one. Okay, so we have a default probability cutoff at 0.5. We prepare something called a classification table, error matrix, confusion matrix. These are all same name given to one concept itself. We might refer it a classification table for now on, so just for simplicity purposes. Okay. Classification table looks like something like this one. Okay, so this is actually the person was having not having an affair, and person having an not having an affair, and person having an affair. This is what is my observed phenomena. And this is my predicted one based on my cutoff. So 0, that I've been predicting that a person will not have an affair, and this is where the person might have an affair. And I have if what is what I predicted, which is my true negative. Person doesn't have an affair, and I also predicted a person has an affair. Similarly, person have an affair, and I also predicted the person has an affair. Okay, that's true positive. So I have a true negative and true positive. Then I have false positive and false negative. A person does not have an affair, and I predict them the person will be having an affair. Okay, that's my false positive. And person is having an affair, and I predicted the person does not have an affair. That's my false negative. So if you prepare this kind of a table, okay, and you need not do it yourself, okay, the now software does it for you without much of an issue itself. Okay. Then you can compare it, and then you can percentage wise how much you were correct. You can compute it as a percentage correct itself. Okay. It's already been generated in your data set itself, okay, and that's what I can be showing. Let me just simply go to the output and make an interpretation there itself. So in this output, I was having is this classification table, which has been prepared for you. Remember, I accepted the default, which was 0.5. Okay, and in the case of 0.5, the person was predicted to have an affair was 431, and person actually did not have an affair was 431. Okay, sorry, 431, and the person predicted was 431 as well. 20 is the person having you predicted that person has an affair, okay, but the person was not having an affair. It's a false positive. Okay. Similarly, the person was not having an affair, and your model predicted pretty well 130, and you have this value 20, which is the person have an affair, and you also predict that the person also have an affair. So we get these percentage correct. 431 plus 20, okay, divided by 431 plus 20, which is my percentage correct. And here it's 130 divided by, sorry, 20 divided by 150, which is 13%. Overall, how much we were correct? Our correct version was 431 plus 20, which is 451, divided by total number of observation, which is 601. So I was correct, accurate to the extent of 75%. That's how the classification table try to represent. Okay. So the same thing which I refer with a different data set itself, okay, so we can predict based on that itself. Okay, so that was the two numbers. Okay, the first ratio which we obtain in the data set, okay, the reported here is a different data set, okay, with some modification. Here, the first correct percentage is referred as specificity, and the second one is referred as the sensitivity. That's a phenomenon which is also used quite often in a medical field as well. Okay? Corona positive testing, okay, might also be using these kind of phenomena for sensitivity and the specificity aspect. So first one is referred as specificity, the second one is referred as the sensitivity. Yeah, these are the phenomena of sensitivity versus the specificity. Okay? That means if you take true positive divided by true positive plus false negative, you get a measure called sensitivity. And you take true negative and divided by true negative plus false positive, you get a measure which is for the specificity itself. Okay. Probably, okay, I'm running short of time itself. Okay, so probably what I'll just show you is that, okay, there are some more measures which has also been there, not quite often, but yes, the classification table and the specificity and sensitivity is a much reported number as well. But what is the idea here is, okay, the idea here is receiver operating characteristics. Okay, so I'll come to that. The idea here is, okay, probably how you decide about a classification number. Okay, so or let me also put it that a paradox which we are saying. Okay, can you be more concerned about the first aspect, which is sensitive specificity, rather than second one? What is this number? 95.6%. So I'm accurate 95.6% in assigning the person does not have an affair, and I also put them as not having an affair. Okay. Vis-a-vis the second one, the person is having an affair, and I also put them, okay, classify them as person having an affair. Okay, that's my specificity. Or 1 minus specificity is, the sensitivity. 13.3% is the sensitivity. Overall, I'm accurate to the extent of 75%. That means 25% cases I'm misjudging it. Okay. So what is probably the misjudgment? The misjudgment is a person does not have a corona, and I put them as that the person is having a corona. Okay. Vice versa, that person doesn't have a corona, and I put it that the person may not have a corona. So those are my two misjudgments which I can refer. But those cases are only 25%. 75% I'm accurate judging the person, okay, in one or the other category. But the answer is I'm plus, okay, probably higher on the part of the specificity and lower on the part of the sensitivity. Okay. At times it will only be defined by the context, okay, whether this first one is important or the second one is important. For example, in the corona positive case, okay, so even if you make a misjudgment, the person has corona and you misjudge, okay, the person does not have corona, and you test them and say, okay, the person has corona. Okay, that's not going to have too much of implication for the society as a whole. Okay, even if you're misjudging a person not having a corona and putting them into category having a corona, so we'll simply quarantine them and will not have a much cost of misjudgment. But the other one is a much more severe cost. Okay, so if a person okay, does have corona, and you simply give them a clean sheet that the person is not having a corona, but that's going to have a much more repercussion for the society as a whole. The people nearby near and dear ones might get affected from the person itself. So at times, in certain contexts, specificity is important. In some contexts, the sensitivity is important. Okay, and it is only a context dependent phenomenon. For example, in this case, okay, person does not have an affair, and you put them that the person is having an affair. Okay, so there is going to be a lot of noise in the house. Okay, as compared to the person who have been misjudging on the other account. The person have an affair, and you give them a clean sheet. The person does not have an affair itself. Okay, that's what okay, may not be such a severe version. Okay, in another context as well. So which one is more important? Is the sensitivity important? Is the specificity important, or both are important? That will fully be dependent on the context. Having said that, 75%, simply looking at 75%, okay, will not suit your requirement as well. Okay, can we change it? Okay, obviously, if my cutoff changes, okay, so does my specificity and the sensitivity as well. So let me just change the cutoff. Okay, I go to the same data set. I again go to analyze, regression, binary logistic. Okay, and in the option category, okay, just look at here. Okay, it says classification cutoff 0.5. I can change it to anything number. Let me change it to 0.8. Okay, and I simply press OK. And now if I see to the classification table, just look at the classification table here. Okay, so there is no affair in the past, and you also give them a clean sheet that there is no affair. Okay, the person does not having an affair. Okay, and you are also right on that aspect itself. Okay, so I will actually increase my specificity in this case. Okay, and here have an affair is person has an affair, you again give them clean sheet that there is no affair as far as the model is concerned. So I'm still right to the extent of 75%. Is there any problem in the data set? Yeah, this is my false positive. Okay, so 451 divided by 601, okay, 75%. So I'm still 75% accurate. In the last classification table, I was also 75% accurate. But in this case, I have a specificity is much greater rather than the sensitivity, which was there in the previous case as well. So I have improved on the specificity aspect. But sensitivity I have lowered. Earlier I was 13% accurate, and here I am 0% accurate. Okay. So these things might matter in a certain context. And this is whole the game of what is my cutoff. What is my cutoff probability? Should it be left as 0.5? Should it be 0.8? Okay, what should be the number? Okay, so there comes our task of saying what is the optimal threshold probability. Okay? What should be the optimal threshold probability? So there are three things which you can use it. One is called as the classification plot. The second one is a Udon index. Okay. Third one is a cost approach. These things can be referred, okay, for computation of what is the cutoff for probability. Okay. So the classification plot and Udon index, okay, that depends upon two graph which has been generated in the data set. It's also been reported. So if you simply go back and just see this, okay, this is my the classification chart, okay, where you can simply specify what is my probability. Okay, remember when I put 0.8, okay, when I put a cutoff as 0.8, beyond 0.8 there is nothing. So everyone will be termed, okay, as not having an affair. Okay, so there is no H and N appearing after 0.8. If I put 0.5, okay, then beyond this person is having an affair. But remember this N which have been appearing in this, okay, after 0.5, okay, they are misjudged itself. Okay, below 0.5, you are simply giving them a clean chip that they are not having an affair. Okay, but then there are so many people who are having an affair. This H represents having an affair, N represents not having an affair. The point below, okay, the symbols which are being put up here in the form of a legend. N means no affair, H means having an affair. That's been defined. So if you put it, let's say 0.05, okay. So if you put it 0.05, then everyone above 0.05 will be termed as having an affair, and below that, okay, you are good on saying, okay, person is does not have an affair. Okay? You are 100% right as well. That's one way in which you can look at the chart and make a cutoff. What should be my cutoff? Okay, probability. The second thing which you can use it is something called as an ROC chart. Okay? So how to prepare an ROC chart? Let me just do that as a final exercise before I actually wind up. I go to analyze, okay, and there's something called as ROC curve. Okay? I click on ROC curve, okay, and I take the affairs, okay, as the state variable, and the predicted probability okay, as my test variable. I put up a diagonal as well, standard score and coordinates. Okay, and the state variable is 1. Okay, 1 is the probability of the person indulge into an affair. Okay, 0 is not having an affair, and 1 is having an affair. I simply press OK, and I get one more chart that's called an ROC curve. Okay, and I get something called as an area under the curve as well. So what does this number just signify? Okay, in that case, okay. So ideally speaking, this ROC curve, okay, which is nothing but, okay, you take sensitivity on the y-axis and specificity, which is 1 minus specificity on the x-axis. You get something called a curve. Which you plot the two, you get the ROC. Okay. I already talked about sensitivity, okay, or 2 positives, okay, to the total and the 2 negatives to the total. I already talked about these two measures, sensitivity and specificity. If you plot them, okay, in a graph, we call something called as a receiver operating characteristic curve, ROC curve. Okay. The ideal situation should be that this graph should be okay, coming from simply shooting up to 1 and beyond this one. That means upper portion should be the ideal position. This is without using any model variable itself. So simply having a constant, no independent variable, should be this red line. This is somewhere in between. That means there is a model which is working sometime and making an error some other time itself. So what I'm doing, okay, how to decide about what is that cutoff? Okay, so the Udon index says if you draw a line parallel to this red line and which touches this particular okay, ROC curve, okay, then that point, that probability, okay, is a best probability for making a classification. Okay, that's what how the Udon index works. And the area under the curve, which is 0.703. Okay. The number which is greater than 0.7 is generally preferred. So we are almost at the margin itself. So my model is working, okay, pretty fine, okay, but my true cutoff is 0.5 only. But if I take a cutoff which is different, 0.8, for example, in the second prediction case, okay, this ROC graph will work. If this area under the curve is less than 0.5, okay, that means your model is not working at all. You should not be using that kind of a model number. Okay. So that should be okay. Some of the benchmark which should be used for classification purposes itself. Okay. Just to wind up on this aspect itself. So the three model which three rather rules which we discussed, okay, for coming up what is the optimum probability, threshold probability, cutoff probability. So one is a classification plot which I talked about, okay, where H and N was been appearing, okay, where pictorially you are able to make that probably which group you want to put it as having an affair and not having an affair. Udon index was giving you the it tells you for every threshold point, you try it with all possible 0, 1%, 0.1, 0.2, 0.3, 0.7, 8, 9, 10. You can go up to from 0 to 1. And what is that number which sensitivity and specificity -1, which wherever is been maximum. So graphically, that's tangent to the diagonal line and having a tangency to the ROC curve. That might help you in giving you the what is an appropriate cutoff. But here again, remember, okay, gives same importance to both sensitivity and scenario, okay, which may not always be true. For example, which I was giving an example of, let's say, corona testing. Okay, having a false negative okay, is more dangerous than the false positive. The person does not have a corona, you tell them the person is having a corona is less severe a case as compared to somebody, okay, where you say that, okay, a person is having does not have a corona and you are telling them the person has corona, okay, because that will not be as serious severe a case as compared to the previous one. So if there are in unequal importance, then in that case you can use the cost-based threshold, where the cost is assigned for the false positive, okay, and the probability of false positive plus false negative into penalty for the probability for the false negative. So you want to minimize that way. So that's one more number which you can pick up for your judgment as to the classification itself. More to do it, okay. Probably that's where I have the time for, okay, and probably I can take up any queries, okay, any other question which you might have at this stage.
Okay. So can we start with the questions?
Yeah, sure. Yes, Anshika. Yeah. Go ahead.
Okay. Yes, sir. So the very first question, ordinal, like children, SPSS, both 0 and 1.
There is some connection issue.
Should I repeat, sir?
Yeah.
Should I repeat the question, sir? Sir, मैं repeat करूँ क्या?
Yeah, sure. What?
Yeah.
Probably I can just look at.
So there is a question, but so the questions are in Q&A.
Okay. Probably there are so many questions open. 51 questions. Okay. Let me
So
just
most of them are asking to repeat the process analysis, calculate how to calculate them.
repeat process of what?
Process of Logit Probit in SPSS.
Okay, Probit you can do it using the generalized linear Werner, analyze and generalized linear and generalized linear model. This is the way where you can approach the Probit model. Okay. And there is you have a dialog box, okay, where you can start from the type of the model. You can select binary Probit and so on. That's where you can actually go for the Probit itself. Okay. The Logit is a much more simpler to run it. Okay, simply analyze a regression, and there is a binary logic. So I'm using only two values of the dependent variable, which is 0 and 1. That makes it a binary logistic.
So next question is by Narayana Swami Sasikala. When there is an ordinary regression, why should a researcher goes for this Logit and Probit model?
The ordinary regression, which is your linear probability model, suffers from 4 problems, which I listed in the presentation as well. But it doesn't ensure that your probability will always lie between 0 and 1, which is the first and foremost limitation. So in the case of this limitation, okay, you might find going for the Logit and Probit version. Okay. So how can you interpret? Okay, probably a simple way the answer is, okay, can you interpret a negative 0.35 as the probability in any mathematical interpretation, any mathematical, not just this one. Okay, so those are the problem with the linear probability model. That's why we go for Logit and Probit.
Okay. So the next question is, doesn't it make any difference that we are taking a variable as nominal scale or ordinal as covariant in generalized linear model?
Yeah, okay, that's not an issue at all. Okay, I referred that 3 such type of variable. For example, age, or let's say number of years of marriage. Now, number of years of marriage is can be anything. Okay, 30 years, 30.5 years, 30.78 years. Okay, could be any number. It's a continuous variable, and I've used that. Okay, that's not an issue at all. If you have something which is an ordinal one, let's marriage satisfaction. 5 is better than 4. 4 is better than 3. Okay, that's not also any issue at all. You can again take it in any regression model, not just a logistic one as well. And the third which I've taken is, okay, for example, the gender, male or female, which is completely a categorical variable. Okay, neither the male is better than the female or female is better than the male. Okay, so there's no order in that case. So that can also be taken as independent variable. So as far as the independent variable is concerned, all sorts of variable you can take it as a part of the independent variable. But with dependent variable, okay, you might have an issue.
So next question is of Ankita Tomar. She is asking, what all values should be reported from the result sections from tables under Probit model?
Okay, that depends upon, okay, that 3 things which you should always be reporting in that case is firstly your goodness of fit measure, which is a likelihood ratio. Okay, unless you have been indulging into model comparison, my model with 4 variable and my model with 7 variable, which one is a better choice? Okay, then you need to interpret a report AIC, BIC, SIC, and all other numbers. Okay, otherwise there is no need. So actually, this will depend upon your objective itself. But primarily, the 3 things you can report is the goodness of fit version, the individual significance of the probability coefficient, the variable coefficient which you have obtained, okay, and a reasonable measure of the goodness of fit, which is your R-squared number. Rather than, okay, now going beyond, okay, if we're looking for classification, which is a very important aspect. People, researchers generally miss out on this aspect. What is your cutoff probability? How much you will assign? Because that's for prediction purpose. If your idea is not to make any prediction, you can skip the entire classification table part. But if you really want to use your model, your model to some use for any future researcher, for any other purpose, then in classification tables, okay, is what you are supposed to be reporting, along with what is your specificity and what is your sensitivity. Yeah. The next one.
Okay. So the next question is of Sangeeta Mukherjee. How does a Probit model work, and what are the limitations and assumptions of it?
There are 2 things which have been there, okay, as part of the assumption. One is the checking the probability itself. Okay, so when you are saying it's a binomial distributed, okay, is it really binomially distributed or not? Theoretically, you need to justify. Second one is a linearity. Okay, so suppose that age if of the marriage, okay, the tenure of the marriage is important variable, but that's not linearly related. That's non-linearly related. That means square of the marriage in years, okay, is also one more factor. So now this will be a non-linear quadratic version of the model itself. Okay, these are the two very important assumption which is been there. Okay, and which I have not checked it. Okay, I have not even tested for you that, okay, the model which I've been using, it I simply adopted as it is. But there would be cross terms, marriage satisfaction dependent upon the gender. Okay, the person who is more satisfied and is a female, okay, might be less likely to indulge into a extramarital affair, okay, or vice versa. So these linearity, okay, in terms of variable, not in terms of the parameter, but in terms of variable, okay, that's one more assumption. So I've already assumed that my model is well-specified model. It might be a baseless assumption, but that is one assumption which is at the back of both the models, Logit, Probit, or including a linear probability model. Second one is the distributional assumption. Okay, so whether you are saying that it follows a normal probability distribution or a logistic distribution or binomial distribution, whether they have been following it or not. So that's by assumption that you have been forcing the data to behave like. Okay. The next one.
So many people are asking when to use, how to decide when to use Logit and when to use Probit.
Okay, so as far as the choice between Logit and Probit is concerned, okay, I was talking about from the perspective of finance. I have more exposure into the area of finance. In finance, there is something called as a fat tail phenomena. The probability of a very extreme event. I am earning a loss of minus 70%, minus 70% loss. Okay, what I predict using a normal distribution is, okay, very relatively lower than what I actually see in real life. In real life, the probability of loss is higher. The probability of extreme profit is also been higher itself. So we are generally having kurtosis in the data set, okay, and higher fat tails, which has been the observed phenomena. So if that happens to be the case, the Logit model is a more preferred choice because that accounts for the fat tail of the distribution rather than a normal Probit-based version. It doesn't account for that. Okay. However, there are multiple versions which you can take. Convention says, okay, using of Logit for, okay, let's say in financial data set. However, mathematics also proves that you can compute one coefficient from the other one, because pi by square root of 3, okay, is a multiple by which you can convert one into another itself. So hence, okay, just to put in a nutshell, from finance perspective, Logit model is more preferred by way of convention. That's more preferred by way of ease of computation. Computing a marginal effects, okay, is also much more simpler in that case as well. But as compared to using a Probit model might also be applicable, okay, when in those cases where fat tail phenomena may not be here. I may not be able to comment on other areas of research like okay, marketing, HR, psychology, okay, and other. Okay, so there the even Probit model might also be more helpful in that case. Probably a choice which you could also do is, okay, apply a simple test is use a log likelihood ratio test, whichever gives you a more better log likelihood. Your goodness of fit parameter, if they have been improving from one model to another one, okay, you can switch to that particular model. But in finance, generally people have a preference for logistic regression model. Yeah, the next one.
Okay, so there is one question by Tribhunath. If P is equals to 0, then how P divided by 1 minus P is equals to 76%?
76%. Exactly, I'm getting 76%. I have not reported anywhere.
The person is also saying the person might have missed something. So want a clarification about this
the only
equation.
thing where 71.6 I reported was in the case of an this one. Yeah, this one was 71.6. I think that's what they have been interpreting in that case. Okay. So if there is no children, okay, so x is 0, then this probability factor I will give you the log of the odds ratio, and if this x is 1, okay, then I'll get another odds ratio. So my beta interpretation will actually be dependent upon how much, what is the impact of in the odds ratio from not having children to having children. How much increase you might experience in the odds ratio, not from the base case itself. It has, okay, probably, it's not that probably I'm not trying, okay, I can try make my best effort, but unless you practice on this, okay, the entire maths I may not be able to, okay, justify at this stage. It only comes from the experience. Reading from the sign is a very simpler task, okay. Marriage satisfaction is negatively related, okay, you also expect it to be negatively related, you get a negative relationship. But as far as the interpretation of coefficient is concerned, that requires some more amount of deliberation from both the sides. Okay, I as a speaker, I have to take one more session only on that, and you as a learner also need to work on that, some of the problems which you can solve on that.
So can we take more questions?
Yeah, go ahead.
Okay, so what model should be used if we have more than 2 dependent variable in binary values?
Uh, more than 2 dependent variables.
Yes,
Okay.
sir.
So probably regression is not the case which you can apply it in that case, okay, because regression has this limitation that you only have one dependent variable. If it is more than one dependent variable, I'm assuming, okay, that means okay, person indulging into an extramarital affair and okay, some other variable, okay, which you might also put it as a dependent. I'm not putting as a category. So suppose there are 3 categories. Let's say there is only one dependent variable, but there are 3 possibilities. Let's say you have been okay, not having a bankruptcy, you are a sound, you are having a bankruptcy, and you are a weak firm. That means you are susceptible to okay, go bankrupt. If there are 3 categories, okay, then the extension is okay, we call it them as a multinomial logistic regression or multi-table Probit analysis as well. So that can also be done. Okay. There is an extension which you can refer to. SPSS also has those kinds of extended model as well. But suppose you have 2 different dependent variables, then in that case you cannot use the neither logistic and the regression or Probit regression. In that case, the only option with you is to go for a structural equation modeling, which can account for multiple dependent variables. Okay. So probably, if I'm understood in the same way, okay, that should be my simple answer to your question.
So the next question is, can the Logit model be applied in behavioral research?
Yeah, sure. Okay. Probably something, the example which I took, okay, deliberately, I don't want to put only finance into this kind of a session, is coming from Psychology Today magazine, published from the US, particularly a behavioral domain altogether. So how does, okay, what is the person's probability into indulging into an extramarital affair? So it can be applied in anywhere where the dependent variable happens to be categorical in nature.
So the next is, why are we using generalized linear model option in SPSS rather than binary logistic and Probit option given under regression?
Generalize, okay, probably it might be other way around itself, okay, when you have analyze generalized least, okay, here you have other options as well. Yeah, so there are more options which have been there, ordinal logic, okay, but it's a more of a wizard where each stage you are supposed to specify. So it takes more number of time. Here you can also do the same thing. That's not an issue at all. Okay, you can run both the models, binary logistic and binary Probit from the same model itself. Okay, but here you have to specify at each stage, okay, what is that you want the SPSS to do. While it's much more simpler to do it from analyze, regression, and the binary logistic. So both will give you same answer, but okay, it's relatively much more convenient to do it one single go, binary itself.
Some of the participants are asking for reference books for Logit and Probit.
The references which you can refer to ND Field, Discovering Statistics by SPSS. Okay, that's what you can read it. Any good book on analytics can also, where classification algorithm has been given. There are so many available out there, okay, as well, that you can also refer to. An introduction has also been there in Gujarati or the basic econometrics. You can refer to some of these literature or this.
Thank you, sir. The most of the questions are exhausted, and the chat session is full of, and Q&A is also full of thank you messages for you, sir, for a great session. I request Dr. Amer to kindly present the formal vote of thanks.
Sure, sure. Thank you.
Thank you,
all.
Dr. Anshika.
Thank you.
Thank you, sir, for giving us the valuable time from your busy schedule. In this session, sir has discussed about Probit and Logit model in detail, techniques that are capable of handling dummy variable, dependent variable, which is primary binary in choice and categorical in nature.
Dr. Amir, your voice is
Amir,
not
voice
coming.
and video.
Oh,
Video.
ma'am.
Thank you.
Okay.
Can we have it again, Dr. Amir?
No need,
Thank
ma'am.
you.
Okay, I'm just been honored. Okay,
Okay.
by the invitation, and it was a good learning experience for me as well. Just pardon me for some of the technical glitches which keeps on popping up. Okay, in any online meeting, not just this one. It was really been a great experience for me as well. Thank you all.
Sir,
Thanks for
thank
your
you, sir. It
Sir,
was
Thank
really
you,
a very
sir.
nice
Sir,
experience,
thank you.
sir.
First,
Thanks, Amit.
thank you.
Thank you.
Thank you, sir.
Thank you, sir. Thank
Thank
you,
you.
sir.
Thank you, Mr. Narayan.
We take a break
We
from
will
here.
start with the
We'll,
next session in 10 minutes.
Okay. Thank you. Thank you, Dr. Anshika.
Thank you.
Thank you, Amir. Thank
Thank
you,
you, sir.
Narayan, sir.
Thank you, ma'am.
Thank you.
Thank you, sir. Thank you, ma'am.
Thank
Thank
you,
you,
Anjali.
ma'am.
Bye, Anshika.
And very big thank you to Dr. Rekha Dayal, ma'am, for being here for the entire session, ma'am. Thanks a lot.
It was actually a learning experience for me also. I think Dr. Narayan was so good that a person like me who's possibly a little weak in this area learned at my age also. Thank you, Mr. Narayan.
Thank you, ma'am.
Your
Thank you, sir.
Professor
Thank
Madhu
you.
Vij is a great friend of mine. Professor Singla is also a very dear friend of mine.
Thank you. हेलो हेलो हाँ जी भैया
Anjali, ma'am, audio.
He is a consultant of data science in analysis for research projects in industries and academics. He is a well-known trainer of big data analytics, machines, learnings using R Orange, Python. And there's a big introduction about Dr. Chauhan, which will require quite a long time, but I'll just sum up with him saying, you guys, please continue with this lecture, and I hope you will enjoy and will learn a lot from him. So I'm cutting short his introduction. I'll just share about him. Dr. Chauhan,
Yes,
welcome to the session. Welcome to the session. We are here to learn a lot from you.
Yes, ma'am. Thank you. And
I'm Dr.
allow me.
Madhava from I've been teaching in DU from 1990.
Good.
And I've been taking income tax and GST and all. And I had a finance background, and I'm sure I'll also learn a lot from you.
Thank you,
My
ma'am.
stock market, I did my research also in stock markets. So I'm here to learn from you, and our participants are also going to learn a lot from you.
Great, ma'am.
So
kindly allow my video and sharing of the PPT.
Dr. Purushottam, can we have sir as the co-host? What's the Dr. Purushottam?
Ma'am, I made it.
Sir, it's all there.
Yeah, now it's ready.
Thank you.
I checked.
Thank you, sir.
Good afternoon. I think I am visible and you can see me, you can hear me. If yes,
yes, sir, loud and clear.
Okay. So the topic given to me is exploratory factor analysis, and which is quite old topic. And I remember that in 2005, when I started my PhD, then my guy told me that you have to apply factor analysis in your thesis. And then I tried to learn this principal component analysis. I visited Ratan Tata Library and many other libraries to find out that what is this factor analysis. And when I start reading the factor analysis, at the time there was no SPSS, no other software, right? At that time, I learned all the metrics calculations and all the metrics calculations. Now, second thing, why to do this? Right? Why we require to apply EFA? So we have to understand that where, when, and why we should apply EFA. So I will give you some of the points. Number one, so you can note down all these things because then I will give you some material also. So, but let me start with the concept. So first of all, the why we should apply EFA. So I will also write my points here. And number one, when we are going to measure something. For example, recently we started one study, and we want to analyze the impact of employee welfare schemes offered by the banks on the stress level of the employees. Now, the topic is actually the impact of employee welfare facilities to the stress level of the employees. So there are some objectives like what are the different welfare activities provided by the banks to their employees. So when we started the topic, and we found that there is no standardized questionnaire available on this employee welfare. Not a single questionnaire was available at that time. Now the biggest challenge that we are facing, that how to develop a questionnaire to measure the employee welfare schemes. So this was a really great problem. Then what we did, we start taking the interviews of different bank employees and find out that what facilities bank is providing to you. So then we can identify different statements. So we identified approximately 40 statements, and all the 40 statements are related to the facilities provided by the banks to their employees. Now the next challenge is that what to do this with these 40 statements, right? Because all the 40 statements are related to different aspects. So we have to club all the 40 statements into some groups, like so that we can say that these 10 statements are related to this area, this 5 statements are related to this area. So the question is that how we can club all the statements. So point number 1, when you are developing a scale, when you want to develop a scale to measure something, you need EFA, because without EFA, it's just impossible to develop a scale. Now I'm giving you a second example. In 2017, the cryptocurrency was at its peak. The rate of Bitcoin reached 21 lakhs per Bitcoin. So everybody was talking about Bitcoin, cryptocurrency, blockchain. At that time, we decided to conduct a research on blockchain technology. Then the problem was that at that time, there was no literature available on the blockchain. So we started again discussing the matter with the experts to find out that what are the different benefit of the blockchain if it comes into the business. Suppose a banking sector adopted the blockchain technology, or the insurance sector or the e-commerce sector adopted the blockchain technology, what will be the impact? So we started collecting the and we collected 38 statements in our research, and then we try to club these 38 statements into few factors or into few groups, right? So this is simply the application of exploratory factor analysis. So exploratory factor analysis will club your statements into few groups, and those groups are known as factors. Right. For a layman, you can understand in this way that you are going to the class to teach something, and in the class there are 60 students. Right. Now the problem is that you want to divide the class into few groups so that you can give them group assignment. So at this point, what is most important, that is group cohesiveness. So you have to form the group in such a way that they have to work together and do some kind of group assignments. So your class, the way you divided your class into the groups, similarly, we are dividing the different statements into few factors. So that is the basic of factor analysis. So number 1, exploratory factor analysis is used to develop the scale. So whenever you want to develop the scale, EFA is required. Okay, so number 1, this is the most important requirement of exploratory factor analysis, that you want to develop a scale. For scale development, EFA is needed. Number two, sometimes in marketing, like in marketing or in HR, we collect the data from the primary survey, and in the primary survey, you can, if you see the questionnaire, right, the headache start coming into the mind. And believe me, if somebody send me to fill the questionnaire, I immediately delete the mail, because filling the questionnaire is very difficult task. So what is the problem? Problem is that the scholars made the questionnaire of 15 pages, 20 pages, right? So who will fill all the 15 pages, right, with reading all the questionnaires? So this is one of the problem in marketing and HR. The questionnaires are very lengthy. So the problem is that when you apply the regression model by considering one dependent variable and many dependent variable, the common problem the researcher will face with the data is multicollinearity. Multicollinearity means when you have load so many independent variables and all the independent variables are found to be highly correlated. So this problem is known as multicollinearity. And I hope in the regression model, somebody will tell you that what is the meaning of multicollinearity. So factor analysis is only solution. I am telling only solution available for solving the problem of multicollinearity. So whenever you face multi-collinearity with the independent variables, you have no other solution other than exploratory factor analysis. I'm telling you that in finance, right? Uh, Even in finance, now I'm giving you some example of finance. In finance, sometimes I applied once. There is a theory called arbitrage pricing theory, and this arbitrage pricing theory say that the stock returns are not only affected by the market, but also affected by many factors. So we try to do this arbitrage pricing theory by taking the returns of a company, and there are different other factors we considered, like we considered exchange rate, uh, inflation rate, interest rate, and then GDP, money supply. There are so many factors, crude oil, gold, and so on. And so we collected the 21 independent variables in the data. All these 21 variables are related to the economic variables, right? So now the problem is that when we applied the regression model, we found that so many variables are facing the problem of high VIF, variance inflation factor. So what to do? Nothing. We have no solution. So we have to apply what? EFA, exploratory factor analysis. So second point is that why you have to use exploratory factor analysis to solve the problem of multicollinearity. So this is the three. Number three, why we are using the exploratory factor analysis. Number three, now you are not interested in developing a scale. You are not interested in solving the problem of multicollinearity. Now you are having another problem. Another problem that you want to identify the latent variable. You want to identify the latent variable. I am giving you one example. In personality, those who are in organizational behavior, or those who are teaching the psychology, if I ask you that how many personality traits you can identify, right? So somebody speaks more, somebody speak less, somebody have high locus of control, some are having less locus of control, some are shy, some are talkative. So personality have different aspects. Now what psychologists do in the initial days, they collect the all the personality features of the different persons and want to see, can we club the similar personality traits into a group, right? So initially they did this kind of exercise and find out that some of the factors I'm telling you, like extrovert and introvert, this is not a single trait, it is a combination of trait. Similarly, social person and non-social person. Sociability is also the representing the set of statements. So all these are factors, and all these factors are coming out because as a result of exploratory factor analysis. So when I say extrovert, it means somebody who talks a lot, somebody who is friendly in nature, somebody who is social in nature. So extrovert is a factor which represents so many things. So when you want to identify the latent factor, then you can go for exploratory factor analysis. So as per my experience, these are the different purpose of applying the exploratory factor analysis. So I remember, repeat, number one, if you want to develop a scale, then you need factor analysis. Number two, if you want to solve the problem of multicollinearity, then you have to do this exploratory factor analysis. And number three, when you want to identify the latent variable, latent means छुपे हुए variable, latent variable within the set of statements, then you have to apply exploratory factor analysis. So I think now you have clarity on this. So we will discuss two cases in this research, in this session. So one session I will discuss, one case study I will discuss for the scale development, and the second is on some multicollinearity problem. So and whatever be the output, I will explain each and everything in the output itself. So let me start the practical with case number one. and I will explain each and everything with the output, on the output itself. So I need 1 minute to open the file. So kindly sit with patience for 1 minute. Okay, so now I'm showing you there are 19 variables, 18 variables rather. There are 18 variables. Actually, the number of variables are high, but we removed some of the items, and the objective of this purpose is to develop a scale. So I'm telling you nowadays what researchers are doing. They are developing the scale, and the process by which they are developing the scale is they are bringing the new concept. Some of the concept I'm telling you now. When we do MBA, when I did MBA, I listen only one concept, that is called brand equity, because this word was used by Philip Kotler in the book. And the brand equity was so popular that our teacher of brand give more focus on this branding. He said that Professor Saklani told us the branding. So branding is very important concept. Every company is going more focus to the brand equity. After that, some new concept comes. Like after that, brand loyalty comes, right? After that, the concept of brand romance come. Then brand love come, right? Now a scholar want to develop a scale on brand respect. So now I am showing you the different process, the steps of developing a scale of the brand respect. Let me open the file first, and I will show you the brand. I will show you the original scale because the data just opened just now. It is a refined scale. So now I am opening the original file so that I can start from the 0 point. So now the case which I am going to discuss is to develop a scale of the brand respect. So this is the data. This is the data, and we are having how many items are in this case? 30 items. So you can see that we are having 30. Okay, 30 minus 3. So these are the statements of the brand related to the brand respect. So basically, all these statements are designed by the scholar with the help of literature as well as with the help of the customers, with the help of brand managers. So some of the items are identified from the literature, and some of the items are identified on the basis of the discussion with the brand managers. So these are the different statements. A statement I removed because the paper is in publication, and these are the different statements of the brand, right? The brand. Now I want to apply EFA in it, and I will show you what are the different steps which are involved in the process. So I click on the analyze, and now you can see the command. I hope it is visible to everybody. So I think the chat box is disabled. I'm not getting any response. Okay, so go to analyze and go to the dimension reduction and go to the factor. So this is the most popular command, and I know that I learned this command initially. It took a long time, but so let's see. And the first rule in this is that you can have only scale items to apply the factor analysis on that. So you can apply only scale variables in the factor analysis. Now, two incidents I'm telling you which are very funny, and but it will teach you something. Once in one of the presentation, one faculty also included the demographic profiles in the factor analysis, and when she represented the result to the panel members in one of the presentation, so one of the panel member asked that why you included gender into the factor analysis, why you included the age group into the factor analysis, right? And the panel member start saying bad words to the presenter. That presenter closes the presentation and go away. So rule number one, you cannot include the demographic profiles or nominal variables in the factor analysis. So you can write the rules. You cannot include the nominal variables like demographic variables in the factor analysis. Number one. Number two, I'm telling you one more incident with factor analysis. So one scholar of Delhi Technical University came to me and say that, so whenever I apply factor analysis, the software say no, I will not run it. So then, okay, so then I saw, no, what is the problem? Let me see the problem, right? So actually the problem is the scholar was doing the pilot survey, and the scholar was having the data of 30 respondents, and there are 50 variables in the data. So then I asked him, you are applying factor analysis on 30 observation, and you are having 50 variables in the file. You want to apply factor analysis on 50 variables with 30 data only. So basically, degree of freedom is minus, right? So rule number two of factor analysis is that the sample size should be at least 5 times should be the number of variables. Like for example, in this case, I am having 28 variables around. So my minimum size to be applicable to apply factor analysis is 5 times of that. So simply 5 multiplied by 28, or if I have 30 variables, minimum sample size I require is 150. So this is the rule number 2. Minimum 5 times is the sample size of the number of variables, right? So these different incident teaches me a lot, and I'm sharing these incident with you. Okay, so after knowing all these rules, now I'm going to the next step. So you can see that after taking the variables into the variables list, I have the option of descriptives, I have the option of extraction, rotation, scores options. So what to select and what not to select, I'm telling you. So first go to the descriptives. In descriptives, we are having univariate descriptive. So we don't want to see the mean, mode, median at all. We don't want to see the coefficient, inverse, significant, determinant. ये सब कुछ नहीं देखना है. So what we have to see? We have to go to reproduce, the most important output we should have, and the KMO and Bartlett test. So now you can note it down. I clicked on the reproduced, I clicked on the KMO and Bartlett. So what this output will be. So I'm telling you now. Reproduce. So let's talk about the reproduced. अब ये reproduction क्या है? What is reproduced? You may be thinking, what is reproduced? So I'm telling you what. So reproduced is a measure of the goodness of fit of the factor analysis. I repeat, reproduced will provide you the goodness of fit measure of the factor analysis. And KMO test will check whether your sample size is adequate or not. And Bartlett test will check, are your variables correlated? If yes, then go further, otherwise stop. So these are the 3 important things. And I repeat, the reproduce means this facility will tell you that how much your goodness of fit is there of the factor analysis. And the logic of reproduce is that the error terms, right? So basically we find out how many error terms are there. Error term means the difference between the actual correlations minus the observed correlation. So if you delete the actual correlation from the observed correlation, I'm talking about the correlation between the variables. So we calculate the correlation between the variables and find out the difference between the actual and after applying the factor analysis. So whatever is remaining, that is called residual correlation. So we want that maximum 30% or 20% correlation should be significant or should be greater than 0.05. Right. So this is the criteria of explaining that whether your factor analysis is of good fit or not. Okay. So I hope I will show you in the output also, and will explain the rest of the part in that. Now KMO, let's talk about the KMO. Basically, KMO stands for Kaiser Meyer Olkin. So Kaiser Meyer Olkin. Kaiser Meyer Olkin exam test will check your sample adequacy. Basically, it is not testing the sample size. So there is a lot of misconception in the market that KMO is examining the sample size. I am telling you, if your sample size is 50, you copy and paste 10 times, right? So your sample size become 50. So I repeat, if you have the sample size of 50 and you copy and paste 10 times, so after that your sample size will be 500. Do you think this KMO will change? No. KMO of the 50 is similar to the KMO of the 500. Why? Because KMO is not testing your sample size. KMO is testing the variation in the sample size. How much variation you are having within the sample. So if KMO is more than 0.7, it means your variables are having enough variation to be captured by the factors. So this is the application of KMO. So KMO examine whether your variables are having enough variation in the observations so that it can be captured by the factors. So this is the use of KMO statistic, and but in all the books it is mentioned that KMO is a measure of sampling adequacy, but it is a measure of sampling adequacy, but it is not a measure of sample size. So that is a problem I found that many people are having in their mind. Now second is the Bartlett test. Bartlett test will check whether your variables are correlated or not. If they are correlated, then you can club them. If they are no correlated, if there is no correlation, there is no point of applying the factor analysis, right? So Bartlett test will check whether your variables are correlated or not. And you know that correlation matrix. So if I ask you which kind of matrix is it? It is a rectangular matrix, it is a square matrix, or what kind of matrix it is? So answer is that KMO is a square matrix. Now, in the square matrix, if somebody have seen the correlation matrix, so what you have in the correlation matrix in the main diagonal? So what number you have always in the correlation matrix in the main diagonal? Okay, answer is 1. I am telling you, answer is 1. So whether the variables are correlated, whether the variables are not correlated, the main diagonal will be constant, always 1. I'm telling you, always 1. Now the upper diagonal and the lower diagonal, right? Lower triangular matrix and the upper triangular matrix. I hope you understand that what I'm saying. The number below 1 and the number below 1, above 1. They are representing the correlation between the variables. So if all these correlations are 0, then the matrix is known as identity matrix. Then this matrix is known as identity matrix. So Bartlett test what do? Bartlett test check the null hypothesis that your correlation matrix is an identity matrix. So this is the null hypothesis of Bartlett test. And if you accept it, suppose in any case, if your Bartlett test is accepting or not rejecting the null hypothesis, it means you cannot apply factor analysis. You cannot apply factor analysis if Bartlett, according to the Bartlett test, you are accepting the null hypothesis, or you cannot reject the null hypothesis. Both are same thing. So for applying factor analysis, KMO value should be more than 0.7. The Bartlett test should have significant probability value. Significant probability value means less than 0.05. So these conditions are required to apply factor analysis. I hope you have clarity on this. Now we are moving further. So as you can see that I selected reproduced, I selected KMO and Bartlett test, and continue, and we can go to the next part, extraction. Okay, so basically this exploratory factor analysis have different methods. You can see that principal component method, unweighted least square, GLS, maximum likelihood, principal axis factoring, alpha factoring, image factoring. Now I am telling you here, 99% of the research scholars, they are using only the principal component matrix, and only hardly 1% they are using the other cases. And even in other cases, maximum likelihood you can apply, not other, because I never apply other than any principal component and maximum likelihood. So 99% you will see the result of principal component, and hardly 1 or 2% you will see the result of other, right? So I will go for a principal component method. Why? Because it gives me the value of eigenvalue on the basis of which I can extract my factors. Okay. The word I'm using like eigenvectors, eigenvalues, all these are mathematical terms. So you just have to know the rules of eigenvalue. The rule of eigenvalue is that eigenvalue should be greater than 1 to be qualified as a factor, right? So in your school days, you have solved the equation problems. Suppose there are two equations, x and y. 2x plus 3y is equal to something, and 3x plus 4y is equal to something. So if you solve these two equations, you will get two values like x and y. Similarly, when correlation matrix, we are having the correlation matrix. When this correlation matrix is solved, so we are having the, if we are having 10 variables, so we will get the 10 values. So these 10 values are known as eigenvalues. Some of the eigenvalues are more than 1. Some of the eigenvalues are less than 1. So we count that how many values are more than 1, and this number will be our factors. So you can see that in the extraction, we are having two options. We can make our factors on the basis of the eigenvalue, or we can decide to make certain number of factors. So most of the people like to click on this based on eigenvalue, and the cutoff eigenvalue you can see here is 1. So the ideal cutoff value is 1. So we will consider only those factors or those components or those roots which are having the eigenvalue more than 1. All other are dropped. So this is one of the important criteria, and in this case you have to click on the scree plot. Although the problem is that this scree plot of the original eigenvalues, not the extended modified eigenvalues. So let's see. I will show you the scree plot also, and we can make our scree plot on our own also. Okay, so scree plot is also there, and let's go to the continue. So in this case, we clicked on the scree plot, we clicked on the based on eigenvalue more than 1, continue, and then go to the rotation. Now there is a mathematical concept of the rotating of the angle, or rotated of the axis, right? So there are two types of rotation of the axis, and we rotate the axis in such a way that they will maintain the 90 degree all the time, or they will or this degree between the axis may be flexible, may come down or may increase. So we have to tell the software that which kind of rotation we want to see. Why we are doing the rotation? Many of you may ask that why we are doing this rotation. Now the problem is that whenever you calculate the eigenvalue, some of the eigenvalues are extremely high and some of the eigenvalues are extremely low. So we have to make some balancing. So we have to come down the higher eigenvalue to the lower level, and we have to increase the low eigenvalues to the higher level. So this kind of modification we need normally. And for doing this, we can apply the rotation, concept of rotation. So this after this rotation, the factors are adjustable to some degrees, maintaining the 90 degree between the two axes, right? That property is known as orthogonal property. Orthogonal property simply means that correlation between the factors remains zero. So whatever factors we are drawing, we want the factors to be uncorrelated, right? So this assumption is there, and with this assumption we are having options of Varimax. So Varimax is the most popular rotation which is orthogonal in nature and will enhance the eigenvalue of the lower factors and decrease the eigenvalue of the higher factors. So Varimax rotation is the most popular rotation and most effective rotation as compared to other rotations. And this Quality Max, Pro Max, and Direct Oblique, they are not the orthogonal rotations; they are oblique rotations. Oblique rotation means whatever factor you will calculate, they will have some correlations. Their correlation will not be zero. But if you apply the Varimax, whatever factors you will calculate, their correlation will be zero. So here it's entirely your choice that whether you go for a Varimax or you are going for other options. So I suggest you you can apply Varimax as well as you can apply Quality Max, Pro Max, not a problem, right? Only thing is that which kind of factors you want. You want uncorrelated factors or you want correlated factors. So this is the logic behind rotation. So, and I also in this case I am showing you the Varimax with rotated solution. Okay. And then we go for a last option, options. So we want to see the factors in the size in the sorted form, and we want to suppress the small coefficients which are less than 0.5 because less than 0.4 because the correlation the factor loadings which are less than 0.4 is to be rejected. We only want to see the factor loadings which are greater than 0.4 or 0.5. Or 0.45. So there are different criteria of giving this option. So I always prefer that whatever factor the software will give to me, they should be sorted, and they should not have a small factor loadings. Okay. So I gave all the commands, and I will go to click OK, which gives me all the output of factor analysis. So let me click OK. And now you can see that all the outputs are here. And let me explain each and every output to you so that you will be comfortable after this lecture. Okay. Now, first thing, the first concept which I am showing you is KMO. You can see the full form of this. KMO means Kaiser Olkin Meyer Olkin. This value should be greater than 0.7. And this is representing the sampling adequacy. For proper sampling adequacy, the value should be more than 0.7. So this is clear. Second point we have to find out is that the p-value, you can see the p-value. The p-value of chi-square should be less than 0.05, right? So the null hypothesis of Bartlett test is that the correlation matrix is an identity matrix. Okay, so because p-value you can see is less than 0.05, so we reject this null hypothesis. So we can reject this null hypothesis because p-value is found to be less than 0.05. So I hope you understand the meaning of this table. So after this table, now I'm going to explain the communalities. Okay. So those, I hope those who are listening me, they are with me. Okay. Now the communalities. So I am going to explain the next concept. This concept is called communality. Communality is similar to R square. Communality is similar to R square. So the definition of communality is that percentage of variations of the included variables. Included variables. So this is the definition of communality. It represents the percentage of variations of the included variables which can be explained by the extracted factors. So this is the definition of the communality. Means how much variation of the items can be explained by the factors. So communality extracted should be greater than 0.5. So this is the condition of communality. Here we can see that this is fine, this is fine, fine. Now this is a problem. This is a problem. So some of the variables are having lower communality. So either we have to drop them or we have to remove them, right? So what we have to do this, we will discuss later on. So we have identified some of the variables like BQ3. BQ3 is having the lower communality. BQ5 is also having the lower communality. Similarly, some more communality may be less than 0.5. So I hope you understand this. What is communality? Communality is simply the R square, which means percentage of variations of the included variables, which can be explained by the extracted factors. Minimum expected communality of the items are more than 0.5. So this is the case of communality. And let's move further. Okay. So here some of the communalities are poor, like 393 is not good. And
sir, you're not audible, sir.
I am audible. Okay, let me. Everything is fine. Am I audible? Hello?
Yes,
yeah,
you are audible.
Yeah, I think I'm audible.
Yes, sir.
Okay. Any problem? No. Okay. So I think Madam is saying that I'm not audible. Maybe, but I'm getting the chat box that I'm audible. Okay. So let me continue.
Yes, sir.
This communality is representing the R square. R square. So I explained you communality, and some of the communalities are poor, and I have to recheck all these communalities like 316 and 393 and some more I have seen 372. So we have to identify that some of the items are having lower communality. Okay. So this thing we have to again check in our next table. Okay, let me move to the next table. So now in this table, which is one of the important table of factor analysis, and let me explain you the this table also. Okay, this table is one of the most important table in factor analysis. Now you can see that there are 28 items. And let me check the 27. There are 27 statements I included in the factor analysis, and let me check the different values. So the first column is representing the eigenvalues. it is the initial eigenvalues calculated by the software. And basically this, if you want to see, if you want to know how these eigenvalues are calculated, basically we calculated the this equation. This is the equation which is used to calculate the eigenvalues. Here R is the correlation matrix, and lambda is the eigenvalues, and I is basically the identity matrix. So the roots of this equation, lambda is a constant. The roots of this equation are the eigenvalues. So we can see that the first eigenvalue is very high, and all other eigenvalues are slightly less. So this problem we are having. Okay, so now if I divide this 7 point by the sum of the eigenvalue, we will get 27%. So eigenvalue upon sum of the eigenvalue is give me the second table, and cumulative is the sum of all. So now I hope you understand this. This is the original eigenvalue. This is the eigenvalue divided by the sum of the eigenvalues, and this is the cumulative. 27 plus 7, 34. 34 plus 6, 41, like that. So we just cut and this and paste here. There is no difference between this and this. All are same, exactly same. Now this third part is different. It is after applying the Varimax rotation. So in the third part, we applied the Varimax rotation, and you can see that this 7 high eigenvalue come down to 3, and all the lower eigenvalues increases to 3 or so. So कम eigenvalue वाले बढ़ गए और ज़्यादा वाले कम हो गया. So basically this Varimax rotation do this kind of change in the eigenvalues. The higher eigenvalues come down and the lower eigenvalues will increase. So this is the benefit of the Varimax rotation. 7 come to 3, and all these lower eigenvalues increases. You can see here. Okay. Now one thing more. So I can divide 27 items or 27 statements into how many factors? 8 factors. So 8 factors, 27 items can be divided into 8 factors. Okay, so after that, this is the eigenvalue, and this is the cumulative percentage. 63 is the value. It means these 8%, no, sorry, not percent, 8 factors explains 63% of the data. Variation in the data, simply variation in the data. So these 8 factors explain 63% of the variation in the data. So this value should be more than 60%, otherwise we will drop it. So this 63% should be there. So I think now we are having clarity on that. And the next table is the plotting of the eigenvalues. So first eigenvalue is this, and after that these are the different eigenvalues. So it is just a plot, nothing to see more than this. And component matrix we don't see. Yeah, reproduce correlations. This is very important. In the last thing, you have to find out this this table. Residuals are computed between the observed and the reproduced correlations. Now read this. Residuals are computed between observed and reproduced correlation, and there are 20% non-redundant residuals with absolute value greater than 0.05. So I am explaining what is this so that you know what we are interpreting. So let me explain the concept of reproduced. Basically, we started with the correlation matrix. So this is variable 1, variable 2, and variable n. Similarly, variable 1, variable 2, and variable n. The diagonal is always 1, and all these values are the correlations. So these are the correlations, and this is the actual correlation matrix. After that, we calculated the factors, right? Now the variables are converted into factors. So we are having component 1, component 2, component 3, and so on. Component 1, component 2, and so on. So this is called component, the correlation matrix between the component, because all the variables become the component after the factor analysis. So again, this is 1, and this is the correlation between the components. And this is called extracted correlation matrix. Now, if the factor analysis is very good, these two metrics should be same. Factor analysis जितना बढ़िया होगा, उतना ये दोनों metrics equal होंगी, same होंगी. And what is the residual? So this is called residual. Residual is the minus, right? So 0, 0, 0, 0, 0 comes because 1, 1, 1 minus 1, 1, 1, 0, 0, 0. And these values are the differences between the original matrix and the extracted matrix. So we want that all these correlations should be less than 0.05. So we want correlation between I and J should be near to 0, right? So the criteria is that more than 70% of the all the values should be near to 0. More than 70% of the correlations in this matrix should be near to 0. So now what is the exact value? I'm showing you. The exact value is 73%. So because 73 is more than 70%, so we can say that the factor analysis is having the good fit, and we are happy. Okay, after that, so this is my rotated component matrix, and in rotated component matrix, you can see that there are 5 statements in the factor 1 which are clearly coming, having this number is called factor loading. So in this table, there are 3 things which you should know. Number 1, what is factor loadings? Factor loading is nothing. It is a correlation between the item and the factor. So this is, and correlation between the item and the factor is known. This is the correlation between factor 2 and BP2. So I hope you can understand this correlation. And second thing, if you do factor loading square, this is square, this is square, this is square, this is square. If you do all this is square is equal to communality. Actually, I suppress these small items, so you are not able to find out it. But if you square all these numbers horizontally and sum it, it will called communality. Similarly, if you do it vertically, this is square, 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 and the last value, you will get the eigenvalue. So if I show you the original matrix without any adjustment, this matrix comes like, if I remove this option, this table actually comes like this. So this is the rotated component matrix original. Actually, I suppressed all the small items to show the factors clearly. Actually, the original matrix is like this. So in this original matrix, if you do like you see the first row, 0.754 square plus 0.244. Let me remove this. Now, if you add this plus 0.187 square plus 0.154 square plus -032 square and so on, this will be equal to communality. And similarly, if I do it in the vertical form, like 0.74 square plus 0.753 square plus 0.749 square, so I am doing it vertically. So the answer will be eigenvalue. Eigenvalue. So we can calculate eigenvalue and community from this table actually. Okay, so I hope you understand that. Now let me show you the original the table which I showed you earlier, because we have to take decisions on factor analysis with the help of this table. Yeah. So after suppressing, this table is actually come. Now in this table, what is the problem? The problem is that this factor is confusing factor, confusing factor, confusing factor, and these two factors are having one factor very low, because all the factors should be greater than 0.5. So these factors are meaningless. They should be dropped. So last 4 factors are confusing, so can be dropped, right? So after dropping these 4 items, these items in the scale, so the refined item, so let me drop it. So I drop BQ2, BA6. So I have to drop it all the items, because these items are having low communality. These items are having they're not giving me the clear picture. So normally after EFA, we have to drop some of the items which are not the part of any factor, right? So because every time you are not getting the right exactly 100% good factor analysis, some of the factors may be confusing. So we can remove all the confusing factors, and so that we will retain back these 4 factors, right? So like let me BA5 BT7. So I started with factor number 8, BA5 BT7. So let me BA5. So I analyze again. I have to remove these items. BT7 first of all, BT7 I have to remove. Then BA5 I have to remove. BA5, and then the BT6 BQ1, BT6 BT6 and BQ1, and BQ4, BQ3, BQ5, BQ is not coming significantly. Okay, so let me do the factor analysis now and see the factor structure. Yeah, so we have to suppress to see all the things clearly. So I am giving the point number 4, 0.4, to remove the numbers which are less than 0.4. Okay, so BQ6 and BA6 is again a problem. BA6 I am removing because it is confusing. It is giving a confusion. BQ3. Okay, so I think I removed all the unnecessary items, and finally I reached to this factor. So this is my clear-cut, clear factor structure. In first factor, I have the 5 items. In second, I have 5 items, 4 items, 4 items. So now I have to give names to these factors. So suppose this factor, by looking at the name, I give the naming of the brand trust. So this is the brand trust. This factor I named as the brand performance, and this factor I give the name of brand brand reputation, and BA means brand acceptance. So all the 4 factors are representing the overall scale of brand respect. So this is the recent factor analysis I applied, and because paper is already got for publication. Now, if you want, I can share the data with you so that you can also extend this concept of brand respect and can write a paper on that. Okay. So now I'm going to show you the example number 2. In example number 2, this is the case of multicollinearity. So no change. I want to do this. Yeah. Now I'm moving to the case number 2. And in case number, in regression, in factor analysis, the problem is that some of the items or the statements which are giving you confused structure, you can drop them. Even negative values, if negative values are coming, so you have to find out what is the reason of negative value. If the statement is negative, you can convert into a positive statement. If otherwise, if there is no meaning of this negative, you have to drop it. So it is an art to develop the factor analysis, right? And now I'm moving to the second case. In this case, the company is going to launch a new car, and they are asking the consumer that will you buy the car? Are you interested in buying this car? So here the 1 means definitely no, and 9 means definitely yes. So the response, it is a 9-point scale, and in 9-point scale the data is collected, and this is the dependent variable here, and the considering buying the car depends upon the these different factors. So all the factors represent the the lifestyle factors, the style of the consumers. So whatever the lifestyle they want to maintain, so all these are independent variables. But the problem is that when I apply the regression, so if I apply the regression with my dependent variable, with my independent variables, and I am clicking on the collinearity diagnostics, you can see for multicollinearity. So the problem that I faced is that my VIF are very high: 6, 6, 9, 10, 8, 7, 5, 4, 5, 5, 13, 13. So I have to apply factor analysis to remove the problem of high multicollinearity. So now I am showing you how to do factor analysis on this. I want factors which may be high, which should be highly correlated, and we can apply factor analysis on that. So let me show you the factor analysis on this example. Analyze regression, dimension reduction factor, and dependent variable I should not include in this, only independent variables. And descriptive, you know that reproduced should be there, KMO should be there, and extraction based on eigenvalue should be there. Script plot I don't require, no research paper is reporting the script plot, so I'm not clicking on this. And rotation, I click on the Varimax, continue. In options, I click on the sorted by size, suppress small coefficient less than 0.4, continue, and now I click OK. So I repeat all these answers once again. Here KMO value, KMO means whether my sample is having the enough variations or not. KMO value is found to be more than 0.7, it is 0.75, which is good. So my KMO test is pass, and I can go for applying the factor analysis. The second value which I have to look is for Bartlett test. The Bartlett test is the probability value is less than 0.05. You can see that the Bartlett table, the probability value is less than 0.05. KMO value is more than 0.7. So these two tests pass, so we can go further. इसमें से कोई सा भी वैल्यू हमारी कम आती तो हम आगे नहीं जाते. So KMO value should be greater than 0.7, and the probability value of chi-square should be less than 0.0005. So these conditions we have to check in first table. Okay, so I think it is clear. Now we can go to the next table. and in the next table, the communality. So all the communality should be high and greater than 0.5 at least. So we can see most of the communalities, there is one problem here, 0.441. So we have to check whether to drop this statement or not. If this statement also has the factor loading less than 0.5, we have to drop it. Otherwise, we can keep it. So this is the criteria we have to check. And other than that, all communities are more than 0.5. So we can continue with it also. Now, in this case, we can see that the 21 items, there are 21 statements. Items and statements are the same thing. 21 statements are there in the analysis, and 21 statement can be reduced to how many factors? 1, 2, 3, 4, 5, 6, 6 factors. And all these 6 factors can represent the 79% of the variance, right? All these 6 factors can explain 79% of the variance of this factor, of these statements, which is a good figure because this value we want more than 0.6 और ये तो 79 है, बहुत बढ़िया, no problem at all. And all the eigenvalues, the first eigenvalue is very high, 4.717. So therefore, this component is my principal component. Principal component means you will get the component in the descending order of the eigenvalue, and the first component is carrying the higher weight. So the first component is explained 22.462% of the variance in the data. So first factor is the prominent factor, which is explaining the 22% of the variance. Second factor explain 13.3% of the variance. Third factor 12%. Fourth factor 11%. Like this. And in total they are explaining how much? 79%, which is quite good. So let's move to the next component. So in reproduced, this number we have to check. So here, actually, okay. So पिछली बार में शायद हम उल्टा भूल गए थे. This value should be less than 30%. Yeah. This value should be less than. नहीं ठीक है 10%. पिछली बार हमारा 23% था ना, less than 30%. यहाँ भी हमारा 30% से कम है. Okay. So this value should be less than 30%, which is good. And we can say that only 10% of the observations, in last example, if I recall, it was 23%. So we can say that 73% of the data are under less than 0.05. Only in this case, only 10% of the observations, are having the correlation more than 0.05. So this value should be less than 30%. So this is the criteria of goodness of it. We have to report this value, and this value is less than 30%. So if you read this sentence carefully, it is mentioned that the residuals are computed between the observed and the reproduced correlations. There are only 10%. Only 10% values are there which are having the correlation more than 0.05. It means 90% of the correlations are less than 0.05, which is a good figure. So we want at least 70% of the correlations are less than 0.05. यहाँ पर हमारी 10% है, पिछली बार हमारी 23% थी. So both are okay, no problem. And now let's move to the next table. So in this table, rotated component matrix. Okay, so we are having the how many factors? 6 factors. In first factor, the factor loadings are quite good. Factor loadings are representing the correlation between the factors and the items, the statements. And on the basis of this statement, we have to give the name of the factors. Like for example, from this table, I am showing you all the statements So my first factor is use credit card, spend for today, like to pay cash, not heavily in debt, seldom use coupons, interest rate are low. So I can give a name to the factors. So in this case, the first factor name is financial aspects. So this is the name of the first factor, and the second factor is this: good physical condition, dress for fashion, stylish clothes look different. So I call it lifestyle, modern lifestyle. And the third factor is I can do anything. Skeptical predictions are wrong. Higher income in future. So it is optimistic. And the fourth factor is consider a leader, self-confident, other asked me to help. So some leadership behavior is coming from this. Fifth factor is do something different, like to travel the world, try new product. So it is called innovativeness, some kind of innovativeness. So factor structure is fine. And the last factor is children's are most important, other spend at evening at home. So it is called family orientation. So in this way, we can find out the factors, we can name the factors on the basis of discussion. And now I want to save all the factors and can give name to them. So now I want to save these factors. So how to save them? I'm telling you. So financial aspect, lifestyle, optimistic, leadership, innovativeness, family orientation. Okay. So after identifying the factors, I am going to save these factors. Go to analyze again, dimension reduction, factor. Now we will use this option called score. So if you click on this score, you can save all the factors, save as variables. There are three options of saving. One is called regression, Bartlett, Anderson, Rubin. So some people say that Anderson, Rubin is best method. Some say that Bartlett is best method. Some say regression is best method. So you can adopt any of the method between the three options. But most of the people, because they don't know what is the meaning of Bartlett and Anderson, Rubin, they click on the regression. So I am also clicking on the regression and continue and okay. So after that, you can see that my factor comes here in the data. Yeah. So all the factors are coming, and the first factor name is financial aspects. Second factor is the lifestyle. And the third factor was leadership, optimism. And the fourth factor was leadership. And this factor was innovativeness. And this factor was family orientation. Okay, so if you remember, the reason of applying factor analysis is to remove the multicollinearity. And let me run the regression now. Now I'm removing all the variables. Rather, I will use only the factors. So I am using the factors rather than using the variables. And I want to see the collinearity again, and Darwin-Watson also. So let's see this. So now you can see that all the variance inflation factor are 1. It means multicollinearity is gone. We have multicollinearity, no multicollinearity problem in the data. So multicollinearity problem is gone, and all the tolerance value, VI value are 1. And 4 factors are still found to be significant. 4 factors you can see are significant. Family aspect, family orientation, financial aspect, family orientation is not found to be significant. And all the other factors are significant. And this 12 is having the highest T value, highest beta value. So innovativeness is the factor which is having the highest impact on the purchasing behavior. Okay. So in this way, we can we can do the factor analysis, save the factors, use the factors. And if I show you the correlation between the factors, let's see, you can see that all the factors are uncorrelated. Now I'm showing you the factor correlation, and you can see that all factors are having correlation 1. So 1 correlation here and 0 correlation in with other. Lifestyle, financial aspect, correlation is 0. So all correlation between the different factors are 0, and this property is known as orthogonal property. Orthogonal property, right? If I show you the any other method, if I applied, suppose rather than giving the Varimax rotation, I give Promax rotation, Promax rotation, right? So in that case, I can also calculate the factors. So these are the factors which I got from the Promax rotation. But if I calculate the correlation between these factors, like, so any other rotation, if I selected, so what correlation you are expected? The correlation are not 0. The correlation they are having some significant correlation. Like this correlation is you found significant. This correlation you found significant. So here you can see that all correlations are not 0, but they are less, right? So you can do the Varimax rotation also. You can do any Promax rotation also. Yes, some of the factors are found to be correlated like this, right? But I think even if we apply the regression, there not be much multi-collinearity with the Promax rotation also. So let me try what level of VIF I got if I apply the Promax rotation. Okay, so here even you can see that multi-collinearity can also be solved with the help of any other rotation. In this rotation also, the 4 factors are found to be significant and 2 are not found to be significant. And if you compare the R square is almost same. There is not much difference in the R square of this and the R square of the previous model. Yeah. So I hope now you are having some clarity on the factor analysis. R square is almost same, no problem. So I have shown you the different cases of factor analysis, and 2 cases I discussed in this lecture. With Promax rotation, there is no difference between the Promax and Varimax. Only thing is that in Varimax, the correlation between the factors will be almost 0, and in Promax, there is still some level of correlation exists. Now, after calculating the this factor analysis, you can apply moderation effect, mediation effect, or t-test, ANOVA test, regression, whatever you want to apply, you can apply on the calculated factors, right? So this is my lecture on factor analysis, and I am open to the queries if any, and I will share the material and everything on my Facebook page. So if within the time period of 90 minutes, I've tried my best.
May I ask, please request Dr. Amir to take up the questions and.
Oh, okay, ma'am. Sir, good afternoon, sir.
Yes, sir.
Hello. Yes. There are some questions in Q&A section that one of the participants asked that what do you mean, sir, what do negative factor loading indicate?
Negative factor loading indicate only the negative correlation between the items and the factors. So if theoretically it is justifiable, keep it, otherwise remove it. So negative correlation, negative factor loading is simply the negative correlation between the factors and the statements.
Okay. So the second question is, in finance, like in arbitrage pricing theory, when we apply EFA, it has to be on stationary variable or raw variable.
Mr. Amir,
No, we applied only on the stationary variables.
Yes, ma'am.
We applied on the stationary variables. We don't apply any of the analysis on the non-stationary variables.
Okay, sir. So there is a question that our participant asked, what is the difference between EFA and CFA?
EFA is exploratory. When you want to develop the factors, you apply EFA. But when you have already built factors and you want to, after EFA, when you want to confirm the factors, then you can do with CFA. Basically, in CFA, we are confirming, we are testing the validity of these factors. So CFA is used for validity and EFA is used for developing the factors.
Okay, sir. So Monica Sani asked, what is the difference between the factor loading and eigenvalue?
Factor loading is simply the correlation between the factor and the item, and eigenvalue is the root of the equation. So whenever you solve the mathematical equation, you will get the answers like x equal to 2, y is equal to 3. So these eigenvalues are the roots of the equations of the that I write on the board. So it is the root, simply root.
So the next question is, can you explain moderation and mediation?
That cannot be explained in 1 minute. These are the advanced topics.
The next question is asked by Dalbi saying, please tell something about cross-loading and validity tests.
Actually, all the concepts comes in CFA, EFA. We know we never see the cross loadings. And in case if one item you found in rotated component matrix where one factor is having high correlation with two different factors, so then you have to think that whether I took this variable in the scale or not. So in EFA we normally drop this item if you are having the cross loadings, right? So cross loadings is not a good feature of EFA. And if in any case you are having the cross loadings, so remove that variable.
So Dr. Dimple Khosla asked, in last example, you told more than 70% of the correlation should be greater than 0. And in second example, you explained so less than. Please clarify.
No, actually, there are two things. One is the number of correlation and one is percentage of the correlation. So number of the correlations is not important. What is important that how much percentage of the value is less than 0.05. So in previous example, the figure was 23%. So it means only 23% of the values are having correlation more than 0.05. It means actually that 73 is misinterpreted. The value we have to check is only the percentage value. That percentage value should be less than 30%.
Okay, sir. So again, Dr. Dimple Khosla asked, how many statements must be there to perform a factor analysis?
At least in factor analysis, 21 statement, 20 statement we should have to apply factor analysis. Otherwise, it is not a logical to apply factor analysis on 5 statement, 6 statement, right? So you should have at least a large number of statement to apply factor analysis.
So the next question is asked by Sonali Lakhera. Sir, how do we decide which factors to remove?
If the if the factor is not meaningful, or if the factor is confusing, right? So it is a subjective issue. So if rest of the factors are enough to develop a scale, then we can remove the unnecessary factors or confusing factors.
Now, the Sonali Gupta asked, is CFA compulsory after EFA?
Yeah. No, most of the cases you have to apply CFA after that, because after finding out the factors, you need to test the validity of it also, because we have to show that our scale is also a valid scale. So in most of the cases, you have to apply CFA after EFA.
Okay, sir. Thank you, sir. There is one question also that's Sonali Gupta asked, which technique to be?
Sir, I think Amir has dropped from the network. There is a question that Dr. Pankaj wants to ask from you. Can I request Dr. Pankaj to unmute himself and ask the question?
Yes, ma'am.
He's
yes,
from he's a teaching faculty at Ramanujan College, sir.
Okay.
yes, ma'am. Actually, sir, मेरा question इसमें ये है
Pankaj, please, you have to be a bit loud.
एक्चुअली सर क्वेश्चन ये है कि इसमें जब मैं फैक्टर एनालिसिस को रन करूंगा तो मेरा ऑब्जेक्टिव क्या होगा, मतलब?
ओके सर, मैंने आपसे बिल्कुल फर्स्ट बोला था कि there are 3 objectives of the factor analysis. One, are you developing a scale? Then you have to apply factor analysis. Are you solving the problem of multicollinearity? Then you can apply factor analysis. Or whenever you want to identify the latent variable, then factor analysis is applicable. In all the 3 cases, the purpose and the objectives are different.
ओके सर, ओके सर। एक चीज और इसमें पूछनी थी कि अगर ईएफए रन करते हैं तो ईएफए जो देता है हमें स्टैंडर्डाइज्ड वैल्यू देता है जो हम कैलकुलेट करते हैं, आई थिंक।
कौन सी वैल्यू सर?
स्टैंडर्डाइज्ड वैल्यू जिनका मीन 0 और स्टैंडर्ड डेविएशन 1 होता है सर।
तो आप फैक्टर स्कोर की बात कर रहे हैं?
हाँ जी, फैक्टर एनालिसिस स्कोर की बात कर रहे हैं, जो फाइनली स्कोर निकल।
फैक्टर स्कोर्स आर यस, दे आर द स्टैंडर्डाइज्ड,
तो इनको हम अपनी स्टडी में कैसे अप्लाई करें?
सर जैसे मैंने आपको रिग्रेशन करके दिखाया था ना अभी, तो you can apply these values as a regression. You can apply these values for moderation, because all the values are further applicable for mediation, moderation, regression for these purpose. You can do the path analysis on these factor scores also.
ओके सर, मीडिएशन मॉडरेशन ये ठीक है, हाँ चलो ये चीज हो जाएगी। तो सर इसमें फिर मैं ऑब्जेक्टिव क्या बनाऊं? अगर मान लो मेरा 4 फैक्टर्स निकल के आए और मैंने मीडिएशन लगाना है, तो इसमें मेरा ऑब्जेक्टिव क्या होगा फिर?
सर ऑब्जेक्टिव हम एग्जाम मतलब एनालिसिस के बाद भी फिक्स करते हैं, पहले करते हैं।
अच्छा, पहले फिक्स करते हैं। ठीक है सर, ठीक है सर, ठीक है सर, मैं समझ गया।
Thank you, sir. Sir, I just request Mr. Amir to propose a vote of thanks. Thank you, sir, for a very nice session, sir.
Thank you.
Thank you, ma'am, for giving me the opportunity. Thank you, sir, for such a detailed explanation. I hope those relevant examples participants understand themselves. In this session, sir has discussed about the probability factor analysis, where it is used to develop a scale to solve the problem of multicollinearity, to identify latent variable, discuss about KMO and Bartlett, also discuss about the Varimax and Promax rotation. I strongly believe that we have availed the benefit of knowledge that sir has gained with years and years of experience and hard work. I thank you, sir.
Thank you, sir.
Thank you so much for taking this session.
Thank you.
Thank you, sir. A very special thanks goes to all my colleagues who are here with me. Dr. Abha ma'am, Dr. Purushottam, Dr. Amir, and the Dr. Pankaj from Ramanujan College. And a very special thanks again to sir for accommodating some time in your schedule, sir, busy schedule, and take this session. Thank you, sir.
Thank you.
Thank you. Dr. Purushottam, can we end the meeting, please?